Here is a Metco system, and will be introduced for us by Chris Gale.
Good afternoon. I'm here to give you a product presentation on the ATC system. I've tried to make the formal part of the presentation reasonably brief in order to have more time to answer questions for you after the presentation. I'm sure that you'll have several questions relating to specific needs for your areas or your customers. If you could please hold them to the end, I'll be happy to answer all of them. In addition, there will be an actual demonstration of the ATC system coupled with an SED gantry robot system after this presentation back in the SED demo area. If Frank would be so kind, we can start the presentation. I have a few slides to show. Can everybody see that? Can the video camera see that? As the title states, ATCS stands for the Advanced Thermal Coating System. It's the latest development in plasma control systems from Metco. We're all very excited about it. It promises to have some tremendous capabilities that were never before present in any plasma control system. It has incorporated many of the best features from the 7MC and 7MC2 technologies, the CPPC, for those of you who remember that, and the latest, the EG88 plasma control system from PEM. The functional modules that make up the ATC system are shown on the next slide, Frank. It consists of 5 major components. Does not look anything like the previous 7MC or 7MC2 consoles. It consists of a rectifier unit, which is shown on the right-hand side of the photograph. It's the Type 20G, which some of you may recognize as the same one used in the EG88. A distribution unit shown in the lower center of the photograph that distributes the power from the rectifier and the cooling water to the plasma gun. On the left side of the photograph is the base unit for the ATC, which contains all the mass flow and pressure controllers for not only the plasma gases, but for the powder feeders as well. On the table in the center of the 3 units is the interface unit, which translates all the information and the electrical signals from the different functional modules to the computer. The computer utilizes an IBM PC. It utilizes its CRT screen and keyboard for displaying all the parameter information and for all keyboard entry and operation of the system. As I mentioned just before, the 20G rectifier is used, which is the same as the EG88 unit utilizes. It's a high efficiency unit, 91% operating efficiency. It has an 88 kW capability. It's got closed loop constant current control. It's got 1100 amp capability. And it has a small, as you can see in the photograph, it has a smaller footprint than most other rectifiers, most notably the 8MR rectifier. The distribution unit is a self-contained unit. It's mounted on casters, though they're not really shown in the photograph. For ease of movement, it can be placed around the room wherever desired or wherever it's convenient. It's small in size, so it can be located where desired. And it includes water quality monitoring circuitry as well. The base unit on the left-hand side of the photograph, the right-hand side of the photograph, is also a self-contained unit. It's also mounted on casters to provide ease of movement and location throughout the room. All mass flow controllers and all pressure controllers for the plasma gases and the powder feeders, as I mentioned, are located in this central unit. There are status lights at the top of the unit to indicate, give local indication of the status of the system. Connections to the powder feeders are by flexible conduit. They're shown at the bottom of the base unit there. They contain all 3 powder feeder hoses for connection to a 4MP powder feed system and allow for quick changeover of the hoppers for the powder feeders. The base unit is available in 2 standard configurations. One is the 2 powder feeder unit, and the other one is a 4 powder feeder unit. And the 4 powder feeder unit is shown in that diagram. The 2 powder feeder unit looks the same, except it only has 2 hose connections instead of 4 hose connections. The base unit has a feature that allows soft start of plasma guns. All plasma guns, regardless of argon or nitrogen operating parameters, are started on argon. This provides a soft light since argon is easier to ignite than nitrogen. And then, if necessary, it's switched over to nitrogen parameters if necessary. This extends the nozzle and electrode life of plasma guns. The interface unit, shown in the center of the photograph, contains proprietary electrical hardware and some software to interface and translate the functional module electrical signals for use by the CRT and keyboard used by the IBM PC. It also has provided in it expansion for future enhancements to this system. This is not meant to be a static system. As you can see by its small size, it's designed for tabletop mounting. The CRT and keyboard is actually an IBM PC. All operating parameters are displayed on the CRT screen. It's available in both monochrome and as a color monitor for color information, color graphics. Overall control of the system and all data entry is by the keyboard of the IBM PC. And parameter storage or recipe storage of the operating parameters is via floppy disk storage on the IBM PC as standard. Now, in addition to these 5 components, there's one more module available as part of the ATC system. It's not shown in this photograph. What we've done is taken the 4NP800 digital feed rate monitor technology, which you're going to hear more about tomorrow in another product presentation, and we've adapted it to work with the ATC system. And Frank, if I could have the next slide. It's shown in this photograph. Without going into detail about the feed rate monitor itself, I'd like to say that with this unit, the powder feed rate in either pounds per hour or grams per minute, the customer's choice, can be displayed in real time and actively monitored and controlled on the CRT screen of the ATC system. Now, since this is being used and it's coupled with closed-loop control of the powder feeder gases, this provides for a giant leap forward in powder feed control and quality for a plasma system. As you can see, it's a fairly compact unit. It's arranged for 2 hoppers in mind to coordinate with the 2-hopper or the 4-hopper system. It's shown here with standard hoppers. It can also accept interchangeably production size hoppers. It's capable of wall mounting. It's capable of table mounting. It's got feet on the bottom of it. And it's also capable of being put on a castered stand for rolling around the spray room. And this is currently being done for a job that we have for Pratt & Whitney. It has plug-in hoppers. There's one single connection that goes to the main conduits to the powder feeders for a quick changeover of the hoppers or change out of the hoppers to production size hoppers. The overall size is not much larger than 2 production hoppers side by side. The control circuitry, the electronic hardware for the digital feed rate monitoring process, is incorporated in a NEMA 12 enclosure, which is completely dust-proof and impervious to the thermal spray environment. And it's located in the gray box with the Metco logo on it. Now that you've seen the actual hardware of the system, I'd like to describe how this hardware works together to put together a coordinated system. Frank? This slide shows a block diagram of how the ATC system controls the different functional modules and the hardware components, and points out some of the additional features of the system. The heart of the system is an IBM PC or IBM PC compatible microcomputer. By using this microcomputer, it allows us to use a full-size printer, either dot matrix with graphics capability or letter quality. This provides a hard copy result of the actual spray process, part by part or item by item, and is particularly important in high technology areas such as aerospace, where a hard copy quality trail is desired or demanded. By also using IBM PC, we can link up with different data highways for factory floor automation. We can communicate with mainframe computers that may be installed in a customer's factory installation. We can use any one of a number of standard data highways. We can use the Allen Bradley data highway, DECnet, General Motors MAP protocol, or a number of other standard protocols. Moving down from the overall control by the IBM PC is the electronic control driver section, which is really the interface module. This does the translating from all the different functional modules and their inputs to a format that can be used by a simple microprocessor such as the IBM PC or PC compatible. This also allows us to use distributed intelligence in the design of the system, what we've done is we've pushed the control intelligence down to as low a level as is practical, and that allows us to use a microcomputer the size of an IBM PC to run the system. The active millisecond by millisecond control of all the different closed-loop parameters that we are controlling is done locally in the different functional modules. Only the set point needs to be sent down from the IBM PC, and only the actual operating condition needs to be sent up from the individual functional modules to be compared against the set point by the IBM PC. If it sees a discrepancy, it will alarm out and tell the operator. If it's far enough out of whack, it'll shut down in emergency mode and alert the operators to what the exact cause of the problem was. I've broken these block diagrams down a little differently than the functional hardware modules, such as the base unit and distribution unit. I'd like to go through them very briefly. We have plasma gas control that consists of individual mass flow controllers that do the active control for controlling the primary and secondary gases, whether it be argon, nitrogen, or helium, hydrogen. Wet collector control, that's an on-off type of control. The wet collector's on or it's off. It's also got a monitoring function to ensure that there is airflow through the room so that you don't build up dangerous gases in the room. DC power and water distribution is through the distribution module. Also monitors water quality as a go, no-go check. Water temperature as a minimum maximum. And water flow as a minimum maximum. Rectifier control is by the active rectifier control is by the 2OG rectifier itself. The IBM PC monitors to make sure that it's maintaining its set point condition. Vent cooling and vibrator air control is similar to plasma gas control. We use mass flow controllers or pressure controllers. Robot control. This unit can be readily interfaced with a robot, whether it be the AR-1000 or a customized SCD design, such as the gantry you'll be seeing shortly. This is go-done type control. The robot will tell it it's in a ready and a start position, and it would like the ATC to advance to the first step of a recipe, which may be a sequence of different operating parameters and different coatings. Conversely, the IBM PC will then tell the robot control that it's reached the set point, it's ready to spray, or that it is spraying powder, and the robot can go and do its thing. The robot system would have its own individual controller. It would not be actively controlled through the IBM PC. Powder feeder gas control is very similar to plasma gas control, only we're controlling powder feeder gases as opposed to plasma gases. The powder mass flow rate monitor, I just went through that briefly before, and you'll get a heavier dose of it tomorrow. The IBM PC constantly monitors the actual mass flow rate that the feed rate monitor is displaying and reading. If it deviates more than a preset percentage above and below that reading, it will alarm the operator and tell him that his feed rate has drifted out of his allowable limits. I've also shown as a dotted box future expansion capability for the system. We don't necessarily know what future expansion it will be. It could be something such as temperature control to actively control minimum and maximum temperatures of a part while you're spraying the coating, or while you're spraying different layers of a coating. It may take other forms. And I've shown not one box but a dashed line past that, showing that additional capability is in the system to take on a number of future enhancements. We're not bounded or limited by what the future may offer. The IBM PC, or the IBM PC approach to a plasma control system, also provides other benefits that I'd like to go through. Frank. It's easy to use. People are familiar with it. Usually many of them are installed in a customer's facility already. And IBM support is behind it. People don't like to argue with Big Blue. The Metco designed software that's used in this IBM PC driven system is itself menu driven for ease of operator use. Frank, can I have the next one? This makes the system very much user friendly. Yeah, you'll have a chance to actually spend some time using the ATC this week. I believe it's Thursday. And you can form your own opinion as to its ease of operation. Don't take my word for it that it's user-friendly. You'll see for yourself firsthand whether it's easy or not easy to use, and I think you'll agree with me. The software for the system is written in a high-level language. It's written in the programming language Pascal, which some of you might be familiar with. The Pascal programming language is itself modular in structure. It's a very structured language. It itself allows modular concepts to be put together and future enhancements to be added on an incremental basis. This also provides for optimum development time and fast response to customers' needs. We don't have to redesign or redevelop the whole system to add enhancements to it. While the hardware and the software can be chosen from a multitude of suppliers, this gives the end user or the customer the best performance tailored for his needs. We need not design custom hardware or custom software, depending on the application, for future enhancements. We're not locked into one company for these boards. They're available from many different suppliers in many different formats. We can take advantage of all that. The ATC controller itself, the IBM PC, can be easily serviced by thousands of local dealers throughout the world, or another one brought in to substitute for it. Metco has also utilized modern computer and telecommunications design techniques in the design of this ATC system. This helps guarantee the user that his system will not become obsolete. We're not fixed in time as technology marches on. We've designed a flexible system, especially one that is software driven, so we're not locked into particular hardware that may become obsolete in the future. The Pascal programming language itself is considered a transportable language among different operating systems, which means different computers. As a result of this modular hardware and software, we can say that the system truly is modular. And this provides the user with performance upgrades as they become available both quickly and inexpensively. A performance upgrade designed for one customer can be easily translated for use by another customer. The ATC system also provides something else in addition to state-of-the-art process control, and that's state-of-the-art maintenance. There's a flight recorder built into the ATC system as standard equipment, and this automatically records all electrical signals for all the process parameters that it's monitoring and controlling for a moving window of 1 minute. It's very similar to a flight recorder used on aircraft. If there's a problem in the system, this flight recorder will capture the data for any malfunction. There'll be no need to try to duplicate a problem that occurs. This can be particularly aggravating when you have a transient condition or an intermittent problem that you can't necessarily duplicate time after time. The data would be already captured. The data then can be analyzed either online or offline on any other IBM PC, even at the customer's site, to determine how the failures occurred. This can also be done at Metco by Metco's field service engineers. Right now, it'll be done by a human operator, a human field service engineer. However, we're looking towards the future where we'll do this analysis by a computer using artificial intelligence. Some people may know it as expert systems, where another computer checks the first computer, or a program checks a program. This data can be sent from a customer's plant anywhere in the U.S. or, and for that matter, anywhere in the world on ordinary telephone lines using telephone modems. And this guarantees that service for this system and from Metco is truly only a service call away. Metco personnel at Westbury will be able to exercise the system with the user's approval remotely back at the user's site using the same telephone modem connection. And he can confirm any diagnosis and ensure that, yes, he's isolated the hardware problem. By doing this, this guarantees that when the field engineer steps on the plane, he already knows what the problem is, he knows what the correction to the problem will be, and he has the spare parts in his case on his way to the customer's site. And he's fully prepared to correct any problem because he already knows what the problem is. On occasion and under certain conditions, some repairs can be implemented by software change. We don't necessarily have to change any hardware. These changes can be downloaded immediately using the same telephone lines back to the customer's site to get him back up and running. For instance, you may have a sticky solenoid valve. There are very close timing signals in the ATC system to ensure precise operation. If you have a sticky solenoid valve, it might be slow to operate. As a result, the ATC will see a fault. It will shut down the system. We can loosen up that timing capability a little bit right in the software. Gets the customer back up and running until the field service man can get there and replace a sticky or faulty solenoid valve. Downtime is minimized by using this type of approach. Now, there were a couple of questions brought up about a 14-year-old being able to call up a customer at 4 o'clock in the morning and completely empty his data bank from the ATC. We've eliminated that possibility by requiring access to the customer's ATC. The customer has to give positive acknowledgement before we can operate his system or before we can access his system. We can't call the customer has to call us. This way it protects his proprietary or confidential data, and we can't access it. On top of that, we can't access his directory in general anyway. We can only access the portion of the screen that the operator or the customer is sending us over the telephone lines. Only what's actively on the CRT screen is what we can utilize. If I can now summarize, right? The ATC features modular hardware and software, and it's a software-driven system as opposed to being a hardware-driven system. We've used distributed intelligence in the design of the ATC. Local control is by the individual functional modules, and overall control by the IBM PC or compatible. We've included communication capability with other machines or computers via Allen Bradley Data Highway, DECnet Highway, General Motors Map Protocol, Texas Instruments Data Highway, any one of the established data highway systems. We've also provided as standard telecommunications capability with Metco Field Service Group via ordinary telephone modems. The system incorporates proven EG88 hardware components, the base unit, distribution unit, and rectifier. Proven hardware. The system itself is upgradable as technology advances, and any expansion or evolution of the system is an incremental engineering effort, not a total redesign. More importantly, the AT system is marketable as a standard product. However, it's a standard product that can be configured for a particular customer's needs, for a particular job, and a particular installation. There's also unlimited program storage via floppy disk drive as standard. We can also provide internal mobile memory, and we can also provide internal hard disk drive. On each floppy disk drive, you can store over 1,000 different recipes. So program storage is virtually unlimited. No other plasma system can provide this capability to the customer. None. This system was designed specifically to allow expansion, so that as new enhancements become available, they can be retrofitted to ATCs already in the field. The ATC is designed to be upward compatible, meaning that older systems are not left behind, they can be upgraded as well. Now shortly you'll be given a demonstration of the ATC capabilities, but before that, I'd be very happy to answer any questions that you have on the best damn plasma system for the thermal spray industry.
My name is Richard Westkevich. I'm responsible for the ATC, and I'd like to introduce Steve Bauman, responsible for the ATC software components. Advanced Thermal Coating System, or ATCS. I'll give a brief explanation as to the operation of the system, and I'll go through the actual inputting of the data and parameters necessary to operate the system. The system itself consists of 5 basic components. The heart of the system is a personal computer. This particular unit you see here is an IBM XT personal computer. Along with the computer, we require a Metco design and built interface box. The interface box is used to send the signals from the computer to an external base unit. The base unit houses the electronic components such as mass flow meters, pressure controllers, solenoids, which are required to operate a plasma gun and up to 4 powder feeder hoppers. Along with the base unit, we also have a distribution unit. The distribution unit houses the water temperature sensors, the water flow controllers, and also mates the water along with the DC power necessary to operate the gun, which is connected to the distribution unit. The distribution unit would operate with any 4 or 2 hose gun available on the market today. The final component is a rectifier. In this case, we have a Type 20G power supply, which can operate up to 80 kW. Metco also provides, for the personal computer, the program. The program is housed on 2 floppy disks. One disk, or the A disk, is the system disk, which will operate the system in either English units or metric units. The second disk is the B disk, which will house the recipe data and the sequence data. The operator would normally see on the CRT screen, once the system is energized, the main menu, as we see here. From the main menu, he can operate the system in any mode that he has available. There is no special skill required, programming skill that is, to run the system. However, it's recommended that the operator does have flame spray knowledge so that he can input the gun and powder feeder parameters. The first operation available is used primarily for duplicating the system and data disk. With this duplicate set of disks, it is possible to go to any other personal computer and...
Computing section 1, begin.
The data diskette operation is used primarily to duplicate the system and data disk. With this duplicate set of disks, it is possible for an operator to go to a remote personal computer, input the two disks, and actually input data recipes and sequence recipes at a remote location. This would enable this particular system to be doing the production flame spray job while another operator is programming the recipes necessary for tomorrow's job. To operate and choose other items on the main menu, only the cursor keys or arrow keys on the keyboard are necessary. By pressing the up and down keys, the operator can move the cursor to the required operation. In this case, I will show the recipe library. By hitting the Enter key, we now pull from the memory the recipe library data. I have the ability to edit recipes, create recipes, delete recipes, or print one or all the recipes in the memory. Each data disk will hold up to 1,000 spray recipes. If more recipes are required, then a second data disk can be used. We will edit a recipe. By pressing the Enter key, all the recipes that I have stored in the recipe library will be shown on the CRT. Again, using the cursor keys, I can choose the specific recipe which I wish to show. In this case, I will choose a demonstration run number 29. If I wish to change this particular recipe, I again press the Enter key and I can change the recipe name. Using the side arrow keys, I can move the cursor to the particular name location and input the desired new revision number. I can then hit the Enter key and store this new name in that place. Likewise, using the primary gas, if I hit the Enter key, a prompt box will again show up, showing me the choice of primary gas which is available. In this case, we will choose argon. To edit the primary gas flow, again, a prompt box will show up, and I can increase or decrease the amount of primary gas flow and store it within the range shown in the prompt box. I do not have to type in the exact value. I can just step up or step down the value required. For safety, if I try to input a range which is outside the value shown, the system will reject the storage of that value. We will input a new value in place. Regulation mode. Again, the prompt box will show the 3 regulation modes available. Mode 1 is a constant voltage mode, which will ask for a secondary gas range and a voltage. During normal operation, the voltage will be held steady within plus or minus 1% of the set point by regulating the secondary gas within the range which I programmed. Mode 2 is a constant kW mode. The system would ask for a range of current and a kW value. The kW value during normal operation will be held within plus or minus 1%, while the computer will regulate the current range within the current range I have input. Mode 3 will hold the primary gas, the secondary gas, and the current constant. The voltage would then fluctuate depending on what hardware I have hooked up and the age of that particular hardware. Normal operation, the hardware would tend to degrade and the voltage would go down. We'll store mode 3. I can now choose a secondary gas. I have the choice, since argon is my primary, of choosing no secondary, hydrogen, or helium. We'll choose helium. Secondary gas flow, again, can be input. The prompt box shows the range available for secondary gas helium. And again, using the cursor up-down keys, we can input the value required. The amperage, I can operate between 250 and 1200 amps. And again, using the up-down cursor keys, we can input the value necessary. If I try to input an invalid input, in this case voltage, since I've chosen mode 3, voltage cannot be entered since it depends on hardware. It is shown as an error, and I will follow the instructions, press the escape button to I can select a hopper bank. I can have, since this particular unit will operate 4 hoppers, any 2 hoppers simultaneously for gradated type coatings, I can choose a bank hopper 1-3 or hopper 2-4. I will choose 1-3. I now must choose the specific hopper I wish to program. In this case, we'll pick hopper 1. And likewise, I can input the carrier flow. We can input the hopper pressure. The vibrator pressure. We can also input the powder port type. In this case, I must type in the type of port and enter it. The material name, which this recipe is designated for. We also have cooling air jets. We have 5 choices. We can make a selection from this list or require no air. Also the type of nozzle we are using. Once all the data is input, it is now possible to save this specific recipe. If I ask to save the information, a prompt box will come up. Being a positive interface, I must then tell the machine, yes, I do wish to save this information. The machine will now go through the recipe library, and it will check to see if I have another recipe with the same name. If I do, at that time, it would then show a prompt box stating, do I wish to overwrite that information? I would have to again state, yes, I wish to override it, or no, I do not. If I do not wish to override it, I would have to go back and change the recipe name. In this case, since I have a new name, it is saved directly. I can now go back to the main menu, and likewise we can re-edit, recreate, delete, or print any particular recipe. We'll return back to the main menu. Once I've input all my recipe data, I can now link them together in a sequence into what we call the sequence library. A very simple sequence would be a preheat recipe, followed by a bond coat recipe, followed by an overcoat recipe. The format used for the sequence library is exactly the same as the recipe library. We can edit, create, delete, or print all of the spray sequences. In this case, we'll edit. Again, the spray sequences, which are stored on memory, will show up on the CRT screen. They are stored in alphabetical order. The name which we select is a 20 alphanumeric character, and a normal name would probably be a part name or a part number, which is to be sprayed with this particular sequence. A disc will again hold 1,000 spray sequences. Each one of those sequences can have a maximum of 9,999 recipe steps. This way, gradated type coatings are quite possible. We will choose a sequence. The sequence I have chosen will show up on the CRT. And on the bottom of the CRT screen, we can see the sequence name which I have chosen, the step of this particular sequence. This happens to be a 3-step sequence. The prompt box shows what's available as far as looking at the next step, the previous step. We can delete steps, insert steps. We can edit the sequence name. We can save that particular sequence, and then we can return back to the main menu. To show you the next step, by hitting the Enter key, we can see step 1 of this particular sequence. The recipe name of this step 1 is preheat 1, and these are the preset parameters for that particular recipe. We will now go back to the recipe menu, go back to the main menu, and I'll explain the manual test operations. Manual test operations are primarily for setup and for checkout of the system after work has been done through the gun, or for checking out powder feeder spray rates. In this case, the first item on our menu is the purge function. Purge primarily would be to purge out and check the mass flow devices in the base unit. This is done by choosing the purge function, by hitting the Enter key. A specific recipe list will come up. I will now have to choose which recipe I wish to operate. We'll pick the first one. And what will happen is the machine will automatically run the primary and secondary gas to the values which I have preset on the set point. In the case of not being able to reach that particular flow, an error message would come up down below telling me to check either the primary or secondary value. It's possible I could have the tank shut off. To shut it off, again I hit the Enter key. We also have available on the menu clear gas lines. Primarily this will be used at the end of the day to shut the system off and to vent the lines of all combustible gases and air. Clearing gas lines, again I would hit the Enter key, and the computer would automatically vent out the entire system. If by chance the operator has forgotten to shut off the gas tanks, an alarm would come up after 15 seconds to notify the operator to shut off the tanks, and the system would shut off. Ignition circuit. We have an ignition circuit test. This is to check out the high frequency circuit and to check out that the nozzle and electrode combination will ignite with little problem. We flow primary gas, argon, and we will also run the water cooling. At that time, the ignition would be energized, and the operator could go outside and check to see that the high frequency is operating properly in the gun bore. Water and gas is primarily used to check for water leaks in the gun. If a nozzle and electrode has been replaced, we can operate the water and gas check. We will run cooling water through the system, and we will run a small amount of primary gas, argon. The operator could then go outside and check the gun for water leaks. Auxiliaries are used primarily to exercise the 6 auxiliary outputs which are available in the system. We can turn any one of those on or off at random. Parameter corrections. Parameter corrections are a very important item on the menu. They're used primarily to set up the powder feeder hoppers. By choosing the parameter corrections, again, a recipe list will come up showing the recipes we can choose from. In this case, I'll pick one that has a powder feeder hopper parameter in it. That particular recipe will show up showing the set point for the powder feeder hopper, in this case hopper 2. We have the recipe name. We have to choose the hopper bank selection, since it's possible to have a recipe with 2 hoppers simultaneously operating. We must choose the one specific hopper we wish to operate. Since we have hopper 2 as a parameter, we must choose bank 2-4. It is now possible to change, before we actually operate that hopper, the carrier gas flow, the hopper pressure, or the vibrator air pressure. Or what we can do is we can turn the hopper on directly by choosing the on mode. The system will automatically operate the carrier gas, which you will see as displayed on the CRT. It will then input the hopper pressure and the vibrator air pressure in the proper sequence. Once it has attained the set point values, it will then tell me that the hopper is on. What is now possible is for the operator to go back, once the system is on and running, and change the various items such as carrier gas, hopper pressure, and vibrator pressure to actually correct the amount of grams per minute being sent out of that particular hopper. In this case, we have a mass flow device hooked up to hopper 2, and as you can see displayed on the CRT, we are flowing 48 grams per minute of 450 material. If I change the hopper pressure, again by using my cursor keys, I will go up. By making a change and using the mass flow device, it is possible to directly change the grams per minute without having the operator to go outside and weigh the material being sent out of the hopper. Stop there. By increasing my hopper pressure, it is possible to increase the grams per minute actually being sent out of that particular hopper. In this case, I've gone from 48 grams per minute to 69 grams per minute. Once I've decided that this is the particular grams per minute I wish to spray, I can now shut the hopper off. Choose hopper off. The system will now ramp down normally to prevent any type of clogging to occur in that particular hopper. Once the hopper is off, it will now display the ability to save this new data in this particular spray recipe. I can now choose to save this new information. If I choose the save box, I will say yes, I wish to save the new value. Again, the system will check on the disk for that particular recipe. In this case, the recipe does exist with the same name, and I must say yes, I wish to overwrite that information. The system will now check to see if any particular sequence is used with this recipe. And again, yes, a sequence is used with this recipe, and I must say yes, I wish to overwrite that sequence. It's used in more than one sequence. I must again say yes, I wish to change it in all the sequences. I have now saved that new information in all the particular sequences I have stored in memory. We can now return back to the manual test menu, and we can return back to the main menu. The final item on the main menu is to operate the plasma gun. Once an operator has developed all his recipes and he has stored in memory all his particular sequences for the parts he wishes to spray, he can operate the plasma gun. By choosing operate, the first thing the system will do is display all the sequences in memory. I must now choose the sequence I wish to operate from. Once I've chosen the particular sequence, the system will now ask me which operating station I wish to operate from. In this case, we have a choice of console or work handling. We will choose console, which is the keyboard station, or we can choose work handling, which would be an outside device, a robot or a linear work handling device. Choosing console, we will operate from the keyboard. The run screen will appear. I have the ability from the run screen to abort the operation or start the operation. The information above will tell me that it's now waiting for the start signal from the console. Below, I have the name of the sequence step, the recipe name for that particular step, the mode of operation, the primary and secondary gases, the current I have programmed as set points, and if I had any powder feeder information, this would show up on the bottom of the screen as my set point. In this particular case, I will abort the sequence and generate an alarm. Immediately an alarm condition occurs and the CRT screen shows the alarm condition. Also, the printer will print out the alarm so I have a hard copy. During normal operation, what is being monitored are all the analog and digital signals in the interface box. The computer is constantly monitoring this device in what we call a flight recorder status. This flight recorder is a 1-minute moving window. New data is entered as old data is expelled. In the case of an alarm condition, what happens is this flight recorder data is automatically saved on the data disk. We use this flight recorder information to send it back to Metco using the modem capabilities of a personal computer so that engineers and the people at Metco could help the customer in determining what possibly could have gone wrong. We will demonstrate this operation in a moment. The system with the modem capabilities, it is possible to take the flight recorder data and, using the modem, call a remote location such as Metco, which we have set up here for demonstration, and transmit that data to Metco so that people there can analyze the data and help the customer attain a reason for a shutdown. I will turn the discussion over to Steve Bauman, and he will explain.
One reason for having a flight recorder is to permit us to look at a problem as it occurs without necessity to try to recreate it after the fact. This is the reason for having the flight recorder, because many of the problems, and particularly the most difficult problems, are those which are transitory in nature and are very difficult to try to reproduce in the field. The data is transmitted in approximately 6 minutes to us at Metco, and we have sophisticated programs over here to analyze this data to try to pinpoint the cause or a possibility of several devices which may have caused the particular failure. The question now is, after we have received this data and have pinpointed the possible causes, to try to go even further and try to pinpoint the exact cause of the failure so that when a field service representative is sent to your location, that he comes with the proper part. In this case, it is necessary for us here at Metco to exercise a particular component at the customer's remote facility. To initiate this, we will call the customer and ask him to call our special number with another special program which will permit us to exercise his machine. And we will demonstrate this capability right now. The customer merely exercises the proper cursor keys, and the call order is automatically placed through the modem capability to us here at Metco. We perform a handshake operation with the customer to make sure that we are connected to the proper customer and that he is connected to us. We now have simultaneous communication where from here at Metco we are actually controlling the customer's machine. We can do just about anything that we would want to be able to. For example, should the customer be trying to operate the unit with no gas or some other particular unit or some other particular easy malfunction, the state of those switches would appear on the top screen over here. This top screen is being updated from the customer's location by the communications link. Should the emergency switch be on or something like this, this particular one over here would be a 0. We will demonstrate this very quickly here, and it takes approximately 1.5 seconds for an action at the customer's side to be reflected on the screen. Obviously, if you try to operate with the emergency switch depressed, not much will happen. Similarly, we can control every single device directly from here at Metco to try to pinpoint a particular malfunction. The bottom screen represents the commands which we are issuing. We will now, on a simple thing, just try to exercise one of the beepers that we have in the unit. We are now waiting for confirmation that the command was issued. We can now check with the customer that is the beeper actually in operation, or is gas flowing, or did a particular relay click in? Did he hear the click directly? And we would know which one it is. In this manner, we are able to isolate faults very quickly and with the proper personnel to try to get the customer back online. many times when there is a real hardware failure, we can sometimes compensate for that by changing the software. To do this, all we would have to do is send him what would be called a software patch. Again, this would be done automatically, and we anticipate we will be able to get the customer back up and running within 1 hour, approximately 50% of the time. Where a component is required, component replacement is required, we will send a field service representative to the customer site. However, he will have knowledge of exactly what is wrong because we have verified that what is wrong here at Metco. Should there still be a problem, we have our design engineers right here at Metco who will be able to look over his shoulder, as it were, with this test screen and be able to determine exactly what additional parts might have malfunctioned. Similarly, we can talk the customer's person, that maintenance personnel, through complex operations by the telephone by monitoring from our location here at Metco all the signals that he might be doing. Again, certain amount of mechanical and electrical ability is required. However, the customer does not have to know every intimate detail of the unit. And we can talk him through, and if he sets a calibration potentiometer or adjustment a little too far one way or another, we can determine that immediately by looking at our screen over here. We are essentially looking over his shoulders as he is actually doing the thing from here at Metco without having to send someone there with the delays that are entailed in such an operation. With this facility, we believe we have conquered one of the biggest problems that many people have against computerized systems, computerized and automatic systems. We have also computerized and brought up to speed the maintenance capabilities of our system, commensurate with its spray abilities. Okay? This is where we ask for questions.
Metco R&D department, temporarily on loan to systems engineering. I'd like to talk about the Metco digital power feed rate module. The purpose of the module is to measure the rate of power feed of each of the hoppers and provide that information to the ATCS, where it's displayed on the monitor with other system parameters. Features are, firstly, that this is a standard Metco systems product and incorporates the same proprietary load cell and circuitry device that's used in the 4MP 800 power feeder rate monitor, which is a standard accessory for the 4MP. The feed rate monitor possesses closed-loop gas control of pressure and mass flow. The feed rate module was designed for maximum functionality and flexibility, with simple rugged construction for longevity with simple maintenance. The unit accommodates standard size or production size hoppers. Here you see with 2 standard hoppers. The feed rate module has a small footprint and volume. That's to say that the entire unit, including circuitry and plumbing, is only slightly larger than the minimal operational envelope for the mounting of 2 production hoppers on load cells. One mechanical fitting incorporates all gas lines to a hopper for quick, easy hopper removal. Fittings are right here. This unit will accommodate standard or genuine power pickup shafts, and the power feed hose connections are adjacent to each other, and the unit can be configured easily to feed from either side. Here you have it configured for the Pratt & Whitney job. We have 2 feed rate modules mounted back to back, and all power feed hose connections come off adjacent to one another. plus it's mounted on a casted frame. The feed hose connections can be put on either side with the same parts, just by switching these parts around. The feed rate monitor needs no adjustment or calibration, incorporates AC line filtering and isolating outputs to the APCS. The component boards are coated with sealant and placed in a dust-proof enclosure. In summation, I'd just like to say that this is a standard Metco product that was designed by Metco personnel for the flame spray environment, and it is an integral part of the APCS. Thank you.
I'm the project engineer for the ARC systems here at Metco. What we'll discuss this afternoon is the coating qualities that we've been able to achieve with the 5R system. In particular, at 500 amps, for these 3 wires, we've been able to achieve the following spray rates: 42 pounds per hour for spray bronze, 48 pounds per hour for Metco number 2, and 27 pounds per hour for aluminum. These rates are approximately 2.5 times the spray rates achievable at 200 amps. The bond strength, 7,700 psi for the spray bronze and Metco 2, and the aluminum AW at 5,300 psi, reproduce essentially the values obtained with the 4R system. Hardness values, RB55 for spray bronze, RC41 for Metco number 2, and RH45 for aluminum AW also match those of the 4R system. These coatings were achieved on grit-blasted substrates with a fine spray air cap. The positive efficiencies range in values from 77 to 77%. Here are some examples of the other coatings that we've been able to achieve with the 5RG arc gun at 500 amps. The top material, aluminum, shows the results of using a fine, fan, and high-profile air caps. The fine, of course, gives us the fine texture. The fan cap is generally used for machining the surfaces after the coating is applied. The high-profile air cap, which gives us the roughest coating, is used for anti-skid applications. The zinc coatings are shown for fine and fan air caps, and similarly the spray bronze and the Metco number 2s. All these coating samples reproduce very closely the 4R coating characteristics. What we'll do now, we'll go through a light-up demonstration of the 5R system using 11-gauge aluminum wire running at 500 amps. The arc spray gun is a machine-mounted gun only. It is used for high production, large piece work. It can spray up to 500 amps continuous capability. The gun drive is a modal drive incorporating a DC permanent magnet motor and utilizing a motor controller which gives uniform wire speed. The front end of the gun, or the head end, as it's sometimes referred to, duplicates the design of the 4RG arc gun head. It allows the uses of primary and secondary air supplies to produce fine quality coatings. Contact tips used for the 5RG gun are interchangeable with those of the 4RG arc gun. The contact tip holder incorporates a similar design to that of the 4RG arc gun by having spring-loaded contact pads to supply pressure to the arc wire, giving it good conductivity to the contact block. The air caps for the gun are interchangeable. There are 3 supplied with the gun: the fine, the fan, and the high-profile air cap. The caps are interchangeable and are simply placed over the front of the gun. Fine air cap is used to get a very finely atomized air particle size. The fan air cap incorporates the use of the secondary air to give you a fan-like pattern to cover large open surfaces. I'll leave the fine air cap in position on the gun for a demonstration to follow. There are no controls whatsoever on the gun for either stopping or starting or any speed control. The arc control unit contains all the controls necessary to control the arc spray process. It has been accommodated now with the secondary and primary air pressure regulators to control the flow rates of the primary and secondary air passages to the gun. The motor controller, or arc amperage control, is as you see here to the left. Potentiometer is used to adjust the speed of the wires, which in turn adjusts the arc amperage level. Wire clamping and motor cooling air regulators are provided to control these two functions. The arc voltage and arc amperage meters are clear and easy to read from the front of the control unit. The control unit employs industrial quality relays to assure for added safety in case of a planned power failure. The 5RP power supply provides all the electrical power necessary for the arc process. It consists of a three voltage range selector knob plus a crank to finely tune the voltage value. The unit is rated for 600 amps continuous duty. The 5RT truck is available to mount the power supply to for easy mobility. There are three members of the 5RP family for international voltages. They are the 5RP, which is at 208, 230, 440 volts, 60 hertz. There's the 5RPE, 230, 380, 460 at 50 hertz. And there's the 5RPE 200 for 200, 450, 60 hertz operation. 5RW wire control unit supplies the wire to the gun. It consists of two carriages, as you see above and below, the lower one being able to be moved forwards for easy loading of the wire by the operator. Each coil of wire is provided with an adjustable wire straightener, which allows the... Each coil carriage also has an adjustable drag feature, so that when the wire stops feeding, the wires become uncoiled from the stand. The unit is mounted on casters for easy mobility. It can handle 11 gauge, 2 millimeter, and 14 gauge wires. The unit is now loaded with 11 gauge aluminum, which will now give a light-up demonstration of the 5R system. To light up the 5R arc system, the following steps are followed. The operator turns on his power supply, and after turning on his quick collector, the power on button, select the switch in the on position. Turn on button.
here to introduce the Type 4 MK refrigerated heat exchanger. Introduce to you the new Metco Type 4 MK refrigerated heat exchanger. This unit...
What's your name?
Oh, my name is...
Let's start over again.
Okay, I'm from Equipment Engineering. And I'm here today to introduce the new Type 4 MK refrigerated heat exchanger. This unit is specifically designed to work with the MN system. It replaces the Type 4ME water-to-water heat exchanger for those customers who do not have a sufficient supply of plant water or whose plant water temperature is too high. A very interesting point on this new unit is that we are using a brand new vendor. We've gotten away from our old vendor who used to make very large systems. The new vendor is tailored to work with OEM accounts such as Metco. He's a relatively small customer, and Metco is very important to him. As such, we hope to improve the reliability and the quality of the units that we sell in the future. The capacity of this unit is the smallest one we make today. Is capable of cooling off a plasma gun that operates up to 500 amps at 80 volts, which is 40 kilowatts. As a frame of reference, the other refrigerated heat exchangers that we have, the CAT 800 is suitable for about 55 kilowatts of operation, and the Type 8MK is suitable for operation up to about 80 kilowatts. As you probably all know, with the other refrigerated heat exchangers, a factory serviceman is required from the vendor in order to start up the unit at each customer installation. With this particular unit, what we hope to do is have our field service people be responsible for the service, for the installation, service, and repair of this device. We no longer will require the use of a factory authorized serviceman. Basically, what we will do for the first 1 or 2 or 3 installations of this brand new product, we hope to have our field service people right there on the spot to make sure that everything goes okay. However, after successful operation, even field service then will be out of the picture, and we will supply this just like before and me. We supply it to the customer, he hooks up the electricity, plugs it into the MCN, and his plane operates it. However, down the road, problems should occur. Our field service people will be fully trained on the operation of this unit as well as the repair, and they certainly will be in a position to offer assistance. I'd like to now go through some of the equipment features as well as the operating controls. This device operates essentially on 230 volts, 60 cycle power, or another unit can operate on 460 volts, 60 cycle power. These units today are not available for use as standard, with utilizing 50 hertz power. For those customers who must have 50 hertz power, a special product request is required. As far as the gun water circuit is concerned, in this area down here we have a 25-gallon water storage tank, and above it, behind this grid, is a small 2.5-gallon make-up water tank. The reason for this small tank above the large storage tank is to keep all the air out of the large storage tank so that the air does not corrode the water-cooled surfaces of the electrode and nozzle. On the far side of the unit is a water sight gauge and also a fill cap to replenish the water which is used up in this small tank during gun nozzle changing. Behind this panel, which is removable by 4 screws, is a water conditioner. It utilizes the same chemical element as that used in the 4ME heat exchanger. Incidentally, do not use the chemical element used in the large 8ME heat exchanger. This chemical element specifically ionizes the water only. It does not deoxygenate and it does not organically filter the water. So therefore, the 8ME chemical element is not suitable here. As you can notice, for those of you people who are familiar with the CAT 800 and the 8M refrigerated heat exchangers, this device is very heavy-duty construction. We have very strong square steel tubing over here, all welded, and individual panels come off. It does not have the lighter sheet metal construction previously used. The front panel of the unit over here contains several items which I can now describe. Thus, the front panel instruments and controls on the front of the 4MK. As is the case with our other units, we do have a water pressure regulator for the gun water and its associated pressure gauge. These are the fittings which feed water to the gun and from the gun. Note that on this unit, we do have valves which turn the water on and off. This is particularly convenient for those installations that require disconnection of the hoses from time to time. We have two temperature gauges over here. One temperature gauge indicates the temperature of the water which is going to the gun. The other one indicates the temperature of the water which is coming back from the gun. A new feature on these heat exchangers are these two pressure gauges which indicate the compressor pressure on the cylinder head as well as the crankcase suction pressure. These are primarily used by our field service department for troubleshooting and to aid in the service of the unit. Contrary to our other refrigerated heat exchangers, this unit comes with a 25-foot long control cable which plugs into the MCN. Our other heat exchangers, as you may recall, had a separate cable which sometimes became lost or was not ordered on the original purchase of the unit. We have quite a few safety features inside the unit to protect the plasma system as well as to protect the compressor. First place on the gun water going to the gun, we have a temperature switch and a water flow switch. The temperature switch is set so that if something should go wrong with this device, and if the temperature goes above 70 degrees, that switch will shut down the plasma system. The water flow switch is set to 2.5 gallons per minute, and at that level, it will shut off the plasma system. Incidentally, this unit will service any two-hose gun that Metco manufactures, except that with the 7MST and the 3MBT, which utilize very low water flow rates, you would normally not want to use it here because that water flow switch may prevent operation. We do have an adjustable water temperature switch inside this box, which the customer can set after his gun is normally operating. He would normally set this thing 5 to 10 degrees above that, so that, for instance, if you're running a MBN at around 3.2 gallons per minute, if the flow should inadvertently drop because of pinched hoses or whatever, the temperature, of course, would then rise, and that switch would knock the system down. We have a relay built into the unit so that if any of the safety devices in the compressor, the pre-stat or the differential pressure switch, should operate to shut the compressor off due to a malfunction in the refrigeration cycle, a relay automatically opens up, shut the plasma system off, so you don't have to wait for temperature and water temperatures to go up or for water flow rates to go down. That, I think, concludes the presentation on the Type 4 MK refrigerated heat exchanger. Thank you.
I'm not quite used to holding a microphone in one hand and a pointer in the other. Well, let's see what we can do. I'm very excited about this project that I've been working on, and I think that the APG system will be a revolution because it offers unparalleled coating quality and reproducibility. Okay, if anybody in the back can't hear me, just raise their hand. Before I begin talking about the APG, I'd like to just briefly review present technology as it stands. In our present guns, as well as our competitors, we have a relatively simple system. It's composed of a cathode, or electrode as we call it, an anode, or a nozzle as we call it. We have either radial gas injection or tangential swirl injection in the region of the cathode, or electrode. We use a high-frequency generator to break down the gap between the electrode and the nozzle. A free plasma emits from the front of the nozzle, and by free plasma I mean one that's electrically neutral. There's no current being carried by it. At this point, powder is injected into the free plasma, carried to a substrate, and deposited. This system has been around for many years, and it works, and it's simple, but it has a few areas that need addressing. One of them is the necessity of the present technology to add a secondary gas to achieve higher power levels by increasing the voltage. Unfortunately, as components wear or are replaced, the amount of secondary, and usually that secondary is hydrogen or helium, the amount of hydrogen or helium that's added has to be increased to compensate. This results in a particle reaction region that's very difficult to quantify. And if you can't quantify it, you really can't determine what its effect on coating quality is. So, now we come to the APG. Now this is a poster. If you give me a minute. Okay. Now, right in front of me is a poster entitled Advanced Plasma Spray Technology, and this was presented at the second All-PerkinElmer Technology Symposium. At this point, we were just in the research and development stage, and it has some areas that are not present in the APG at this time, but will be in the future. But the salient features are, and their basic operation are evident in this poster. First of all, the advanced plasma gun system allows operation up to 80 kW without secondary. This is accomplished by use of a closed-loop electromechanical device which actually alters the position of the electrode. Thereby, instead of using a secondary gas, you're controlling arc voltage by arc length. Now, we'll be going between this poster and this assembly drawing. I hope you can all see clearly what's going on here. We have the electrode connected to a stepper motor. Inside and not represented here is a proprietary electronic circuit. This circuit measures the voltage across the gun. This is a first, and it's of great importance because for the first time, one needn't worry about the cable configuration or the individual console that's being used for the spraying process. Since voltage is measured at the gun, the line losses are are accounted for because they're downstream of where the voltage is being measured. Now, when the APG is used with the 3M system, the 7M system, the 7M2 system, one needn't worry again about these line losses because they're compensated for. The way the gun is operated is upon ignition, which is preset for the given parameter that the person wishes to spray. The circuit senses that the voltage is too low. It sends a signal to a stepper motor, which is incorporated in the housing of the gun, and that retracts the electrode until the voltage measured is equal to that of the voltage preset. Now presently, with the API of the interface unit, that voltage can be maintained to plus or minus 1 volt. That is a result of the limitations of the the meter that we purchased. This meter is hardened for the welding industry. It's not affected by the gun ignition, and we've also filtered it to guarantee that. But when used with a system such as the ATCS, where the voltage that the person desires to use is set by software, this accuracy can probably be plus or minus a tenth of a volt if the operator feels that that kind of critical voltage is necessary. So to reiterate, we have a closed-loop electromechanical system that positions the cathode to give an appropriate arc length that gives us an appropriate voltage as preset for spraying the powders. Now, in order to accomplish this, we have what we call a segmented nozzle. The reason the nozzle is segmented is because if one were to work with the original technology, and I hope I can still show you this, if one were to move the electrode back, all that would happen would be that the arc would follow it along the contours of the nozzle. So, in essence, the segmented nozzle sets up a series of barriers so that the arc tries to cross this barrier and stop, thereby allowing the moving electrode to extend the length of the arc. Now, the second interesting feature is the use of single gas, and we're using argon. The reason we're using argon is because, first of all, it's not as harsh on the components of the gun as nitrogen or the addition of secondary hydrogen would be. The second reason we're using argon is because we're addressing this particular gun to the aircraft industry. Argon is the preferred gas, and being able to go to 80 kW without secondary of any kind eliminates the concerns for nitrogen and hydrogen embrittlement. The result of a moving cathode in conjunction with argon is very interesting because as the gas is injected into the plasma gun, it travels along an extended arc, thereby being heated to a greater degree than can be presently accomplished in a short electric arc length. So the temperature profile that comes out of the front of the gun is more of a top hat or a square than the typical parabolic one which is presently achieved in our present technology. What we're doing there is we're chopping off the sensor region which is hotter, but we're trading it in for a much larger reaction region. And as you'll see during the demonstration of the gun later, you get a much fuller plume. The advantages of a fuller plume are that no matter where you inject your powder, you're going to get the same coating. Because in present technology, if you don't have if you do not fill up the bore of the nozzle, depending on which side of the nozzle the plume is standing on any particular day, the powder injection can give you different coatings, even though to the eye nothing has changed. Another interesting feature is this vortex generator, which injects gas at the base of the electric arc where it rides on the nozzle surface. Now I'm going to try and explain simply what it does. First of all, it aids in arc stabilization, and the way it does that is by swirling the gas rapidly, the colder gas is sent outward because of angular acceleration. What this does, it tends to concentrate the core of the plasma, giving you a hotter plasma, and at the same time leaving a layer of colder gas around the nozzle. This will give increased nozzle life. Additionally, the gas injection is being directed in the region where the plasma arc is taking root on the nozzle, and what happens is, as this cold gas bypasses the plasma at the root, and it will bypass it because the plasma is very viscous and acts as a rigid body. So what happens is in the region of the stagnation, which is the back end away from the gas flow, the area is hotter. And since the plasma, like most electric circuits, takes the path of least resistance, it wants to follow that, thereby increasing the rotation of this root along the nozzle. This again aids in nozzle life. And we have some nozzles which have over 100 hours that have nothing more than a frosting to show where this arc has been rotating. Now I'd like to go back to this drawing and show you some of the salient features of the gun as it is. I've mentioned the moving cathode, I've mentioned the stepper motor, I've mentioned the proprietary electric circuit. Here we have the segmented nozzle as I told you. We have copper water-cooled discs insulated by dielectric materials that allow us to achieve, under proper conditions, voltages of up to 110 volts. We wouldn't recommend that as an operating voltage because with the 7MR that's well beyond its capabilities in terms of its volt curve. But we have routinely obtained 100 volts. At this point, I'd just like to go back and talk about what effect this polar plume has on the coating. Because we do have a higher polar plume, we have been noticing that we are getting higher spray rates, higher deposit efficiencies, and improved, or actually not improved, but less target deviation. I have here two DE plates which tend to give the upper and lower deviations. Since the ceramic material is sprayed into a low velocity plasma plume in order to give it a higher residence time, the target deviation would be the greatest. And here we have a panel of 204B, which I'm told is a ceramic material. It has a 65% DE, and the target point deviation is approximately 1/8 of an inch. I'll pass this around. A lighter material, or excuse me, not a lighter material, but something like 601, which is a plastic material with aluminum, am I correct? Okay. Would be used with our higher velocity nozzle, and that would give us the least target point deviation. And here we can see 601 sprayed, 80% DE. Bill, was it 10 pounds an hour? 10 pounds an hour, and the target point deviation is approximately 1/16 of an inch.
Tom, what do you mean by target point deviation?
Well, if you have a plasma, let me get my pointer. If you have a plasma plume coming out of the bore of a gun, and you're injecting powder, just the physical effect. If you go back to your basic physics, and if you have a force in one direction and you push it with another force, the direction is going to be the resultant of the two. So what that means is anytime you're injecting perpendicular to the flame, it's going to deflect that flame, and the powder is not going to be deposited on the center line of the bore. But again, if you come back to the fact that we have a square temperature profile, the powder, as it comes into that region, is going to be in there a lot longer, become plastic sooner, and be able to follow the streamlines of the plasma quicker than if you have a parabolic profile. I also have a typical cathode, which is unlike the present-day cathodes. We have run this at 1,000 amps, and to date, after several hundred hours, we never had to change one. At this point, I'd like to talk about the fact that we only have 3 nozzles at this point. We have one which is called the 310 nozzle, which is a large bore. That's for low velocities. Ceramics like 204 was sprayed with the 310 nozzle. We have a 305 nozzle, which is a medium velocity nozzle, and I have an example of that here. And by the way, if you take a look, you'll see the vortex injector holes that are drilled into the nozzle, so that each nozzle... No. Each one of the tangential injection holes are again directed so that they do impinge on the base of the electric arc. And then we have the 300 nozzle, which is a small bore. It's used for tungsten carbides and 601s. And we've noticed that it generates shock diamonds, which is very difficult to achieve in plasmas at lower levels than has been seen before. At this point, I'd like to address any questions from the audience.
.800 powder feed rate meter. The meter is a device which will give a real-time indication of what the powder feed rate is in engineering units. It's been designed to reduce our customers' operating expenses and to help them produce better quality coatings. All right. I'm sure you're all familiar with the manual method of taking spray rates. The method's good for setting up a feeder, but it doesn't tell you what the rate is while the guy is spraying the part. As a result, he winds up with rejected parts occasionally if the rate changes while he's spraying. You also waste a lot of material when setting up the feeder, and you also waste material due to changes in deposit efficiency if the rate should change because it changes the manifold pressure or beginning to run out of powder for whatever reason. The 4MP800 automatically weighs the hopper continuously, and it looks at the changes over time and gives a display of grams per minute or pounds per hour, the case may be. Since the guy can see the rate now, all other things being equal, he'll wind up with more uniform, predictable coating thickness on every part he sprays. It also will give him better operator supervision. He can have his foreman walk through the shop, and at a glance, the foreman can tell whether his operators are spraying at the proper rate. Also, if he's spraying a long job, he now has the ability of making adjustments on the fly while he's spraying the part. He can, make, if he sees his rate comes down a little bit, he can make an upward adjustment in hopper pressure with a 4MP. All right. Product features. It's been designed as a retrofit kit. It's steel installable in approximately a half hour. It requires drilling 4 holes in the top of the 4MP if the guy has an existing 4MP. New units will have the holes already in them. And it also involves removing the bracket and replacing it with a stiffer bracket designed to support the weighing device. Also, it's a direct method of measurement. The powder mass flow is determined directly from hopper weight, as I mentioned before. All right. Also, the amount of powder you can put in the hopper is only limited by the hopper volume. There's no inherent weight limitations due to the weighing device, which is a load cell, by the way. A production hopper can hold up to 75 pounds of the tungsten carbide powder, and that is the full-scale load capacity for this application. All right, the unit will give real-time indication of the powder mass flow in either grams per minute or pounds per hour, and that's switch selectable. There's a toggle switch on the back of the unit. Also, Also, other than that one adjustment for selecting the units, there's absolutely no calibration or operator training required. There's no setup other than the initial installation, which is all mechanical. All right, the accuracy we've observed on the unit has been quite good so far. All right, it's never exceeded more than approximately 0.3 pounds an hour in the 0 to 50 pound an hour range. In the 50 to 100 pound an hour range, we've seen as much as a pound an hour difference, which is still only 1% of reading, which is quite good. All right, the resolution on the display, it'll tell you what the rate is to the nearest tenth of a pound an hour in the pound an hour scale, or to the nearest gram per minute, if he's using grams per minute units. Also, the time base on the unit is 1 minute when the powder flow is steady. Just like the guy sprays into a bucket for a minute now, it gives him a 1 minute average during steady state. However, during transients like startup, shutdowns, out of powder, or whenever the powder flow is changing, the averaging period shrinks down to something on the order of 3 seconds. So it'll show them it'll respond to changes much more quickly. And that about sums it up. So if there's any questions, yes.
7, coatings and the coating development work that has gone on to meet with that specification. Bill Rush. Thank you.
So I'd like to give you an overview of new 257 hardware and the coatings you can produce. Let me just give you a little background on the situation. As you know, Pratt & Whitney 257 calls for a coating with pH micro hardness of 900 to 1200. In the past, Metco has not been able to produce this coating, or if they can, it's only been, you can produce it one day, and the next day you can't get it again. We've developed special hardware, which includes a new nozzle, a new powder port, and a new powder port pickup shaft for the Form P, which will give you better powder injection and reliably produce this coating every time. This hardware has been matched so that if you don't use the number 7 powder port, or the C shaft, or the 738 nozzle, you won't get the coating. You have to have all 3 present in order to get the coating. What the C shaft does for you is it gives you a very uniform powder flow. Any fluctuations, any pulsations will make the coating not come in. Also, number 7 powder port is matched with the C shaft to give you this flow. If the number 7 powder port wears a few thousandths, it'll go out and you'll get either flow fluctuations or the powder won't go into the flame correctly and won't get the coating. The number 7 powder port is designed to have a life of 8 to 10 hours. Because the tungsten carbide powder is so abrasive, it wears the powder port very quickly. And the powder port has to be changed after those 8 to 10 hours, otherwise the coating won't come in either. Similarly, the C pickup shaft also has a life of about 40 hours. It can be checked to dimensions, but usually after 40 hours you'll wind up changing the C pickup shaft. And when a coating like this, being so critical, it shouldn't be that much of a problem to change the shaft or the powder port. The 738 nozzle will have an average life of 10 to 12 hours if a AME heat exchanger is used at 120 psi. If you use regular city water, you can still get the coating. There's no problem, but you'll have a lower nozzle life. This coating must be sprayed using work handling. If it's sprayed by hand, you won't get the pH hardness. We recommend that it be sprayed at between 125 to 150 feet a minute, although it can be sprayed faster. Parameters that have been developed are for a 7 MB and 9 MB will work with either gun. If the parameters are changed a little bit from what they say, it can still come in, but not more than a couple of points. The parameters call for 150 over 20 argon helium flow. You can go to 19 flow in a helium with 21, but any more deviation that is not allowed. We recommend that you do not adjust the secondary flow to the same voltage. Just let the voltage flow where it's supposed to go, and the helium flow is more important than what the voltage is for this coating. The technical bulletin for this coating has just been issued, and you should either be getting it soon if you haven't gotten it already. The These new hardware parameters also work very well with 72F and 82VF to meet the 67-2 specification. It also works well with 73F and S-1, giving more consistent coatings and a higher DPH hardness without cracks. This hardware will be in stock as of October 1st. And that's all I have to say. Is there any other questions?
I'm here to talk about a new addition to the powder feeders, Form P powder feeders, that is. We coined the phrase Gemini pickup. What that really means is it's a multiple powder port shaft. A standard with the feeder, you get a powder port shaft that feeds out of the hopper via one powder hose. This new retrofittable device, which fits into a standard Form P hopper, allows you to equally divide the powder feed rate in half. Carry it through two powder feed hoses towards the plasma gun. And we basically designed this for three main reasons. The first is to get higher spray rates. The second one is now, with this device, you can essentially use one feeder, whereas previous to this, you had to use two feeders in some applications. Spraying 465 in the boilers, for instance, you had to use two powder feeders for one plasma gun. With this device, you now only need one powder feeder. In the turbine industry, where they spray the compressor sections with an abradable coating for clearance control, some applications require several hours of spray time. With this device, because you can get higher spray rates, you can effectively cut your time in half. Another feature of this device is it equally divides the feed rate in half. There's no tweaking on one side or the other. Now, I have a demonstration in the lab, but you can't see it operate here. Are there any questions?
Good morning. Good morning. This morning, I'm going to give a short presentation on the Metco 5R arc spray system. It's a new, heavy-duty, high-production arc spray system. The system features a high spray rate capability proven and tailored for production work or for large pieces. The spray rates are 2.5 times that of a conventional 200 amp system. The system uses primary and secondary air supplies as was similarly used in the 4R arc system. The system is capable of feeding 11 gauge, 2 millimeter, and 14 gauge wires that Metco supplies. The Type 5RG arc spray gun is a machine-mounted gun only. It has an electric motor pull drive which offers uniform wire feed. The high-performance DC permanent magnet motor is also air-cooled. The gun head for the particular gun has been modified to include primary and secondary air passages very similar in design to the 4RG arc gun head. The gun is supplied with 3 interchangeable air caps, the fan, the fine, and the high profile. The fan cap is used to give you a broad pattern to the spray stream for doing large open surfaces. The fine spray cap is used when very fine atomized particles are desired to obtain very smooth as-sprayed coatings. The high profile cap is used for anti-skid work and gives you very rough coating textures. When using different wire sizes, only the contact tips and drive rollers have to be changed from the gun. And the drive rollers only have to be changed for the 14 gauge wire. 2 millimeter and 11 gauge wires utilize the same drive rollers. The Type 5RC arc control unit has all the controls necessary to control the arc process. There are no controls whatsoever on the gun. control unit incorporates separately and infinitely adjustable pressure regulators for both the primary and secondary air supplies. The control unit also has remote location capabilities if the customer chooses to locate the control unit outside the workstation. The control unit also incorporates industrial quality relays for added safety. What this means is if the customer should lose power in this facility, the relay is open, and to restore the operation, an operator has to reactivate the buttons. The arc current and arc voltage meters are on the control unit for easy readability. I might also add that the front panel of the 5RC will be similar in appearance to the 4RCR control unit. There will be a 3-position mode selector switch for wire feed, air adjustment, and spray. And there will also be a power on and a mode on button very similar to the 4RC control unit. In addition to which there will be a potentiometer knob on the face of the control unit which adjusts your arc current.
There also one on the gun or not?
Nothing is on the gun. The Type 5RW wire control unit can handle 14 gauge to 11 gauge wires. It's provided with wire straighteners to straighten out either the stiffest wire or the softest thin wire. The bottom coil carrier of the 5RW can be pulled out to make the loading of the lowest spool of wire easy. The control unit also offers the adjustable wire drag for each of the carriages so that your wire will not uncoil when gun operation is stopped. The whole unit is mounted on casters for easy mobility. A demonstration of the...
So we'll present this product to you today. Or am I correct in saying that? Okay. Hank, come on up.
Here today to introduce the new Type 4NK refrigerated heat exchanger. Marty and I are the people in the engineering department who will support Elliot Sampson and his crew. So if you have any questions before installations or during installations, or perhaps down the road a year or two if you have any problems, and if Elliot and his gang can't help you, Marty and myself are here to do it. As a response primarily to some of the questions from the new salesmen, for those people who either have water which is too hot or which have no water at all, what we did do is we came out, we got a brand new vendor, and now we have this 4NK. It's been specifically designed for use in the MN plasma system. Now what that means is that it's good to operate a gun up to about 40 kilowatts. We're talking about 500 amps at no more than 80 volts. You cannot use it on a 9MB, for instance, that can run up to 80 kilowatts. It does not have the cooling capacity. It's a welcome addition to our line in that we have gotten away from our previous vendor. Many of you people have had problems with that previous vendor. We're now going to a new small vendor. The guy's name is Capital Control. He's in Old Lyme, Connecticut. It's a relatively small company, and Metco is a big customer. With Dun & Bush, our previous supplier, we were just a small little tidbit of his business, and he didn't speak too well back and forth with us. In addition to all this, Capital Control is primarily interested in dealing with original equipment and manufacturers like ourselves. Dun & Bush, 99.9% of their business were with mechanical contractors who put their equipment into buildings so they could get away with delivering equipment which perhaps was leaking a little bit or not quite up to snuff. That's not the case with us. Shortly we'll be going out to the field service booth, and we can show you the one unit that we have. That's been fully tested at the vendors. It was brought back here, and during the last 3 weeks, Marty was good enough to test it on argon hydrogen as well as nitrogen hydrogen. And I can tell you that we probably have, at a 90-degree ambient, about a 20% factor of safety with the gun running wide open at its rated capacity. Another major cost-saving feature that we built into this thing is that we're going to do away with the upfront installation costs required by Don Bush for all these years. The ultimate intent is that these units will be shipped directly from Metco to the customer. The customer will start this thing up in a similar way to the way he now starts up the NN system. As you all know, before it required Don Bush's aid. If problems should occur, Elliot Sampson and his people are fully trained on the use and operation of this thing, so they are equipped to do all the service, with the exception of one item, and that is if a freon leak occurs, they will understand how to fix it. They will, however, have to subcontract a local refrigeration mechanic. The reason being, you need a vacuum pump in order to evacuate the system. Vacuum pumps don't fit into a cachet case when they travel. I think Marty and I did a reasonably good job on this thing, and that we tried to keep the cost as low as possible. We went out, we got quotations from 4 or 5 different people, and we chose Capital Control, first of all, because he had a very good product, but his particular scheme also results in a low-cost unit. One of the major reasons why the unit is low cost is because it's in the capacity that we run. We can use what is known in the industry as a fully hermetic compressor. That is, the motor and the compressor itself is all put into a welded container, and this makes for a less expensive construction than the semi-hermetic, where you have a separate motor and a separate compressor. To give you a brief relationship between the various units we have, the new unit, like I said before, will handle about 40 kilowatts. The Cat 800 is rated for about 55 kilowatts, and of course the MK, 8MK, is rated for 80 kilowatts. That's about the end result of one other minor point, and that is the unit is only available for 230 volts or 460 volts, 60 hertz. At this time, maintaining the cost and size, etc., it is not possible to make this device in a 50 hertz unit. For those 50 hertz applications, we would have to get a special product and go through that to find out what the cost would be. Are there any questions?
You know the cost of one now?
I know the manufacturing cost. Andy Mazzone hasn't tipped me off as to what he does with that. I can tell you
as much as he can.
Yeah, right. I can tell you it's considerably less expensive manufacturing cost than the Cat 800. I hope so too. Yes. The thing is designed so there's a plug on the back of the MCN where these 4ME heat exchanger plugs into. If you wish, you unplug the 4ME and you plug in the 4MK. It's a one-for-one change. And Tom, with respect to some of your problems in the past, the unit does come with a 25-foot long cable, and you do not have to worry about buying a separate cable to hook up the refrigerator heat exchanger to the MCN.
Give us some idea of weight and dimension.
You get a very good idea when we go out there into the demo area. It's in the order of 800 pounds. Weight, it's approximately 2 feet wide, about 3 feet high, and about 4 feet long. And as is the case in all of these devices, the size is primarily defined by the size of the condenser. We pick the ambient temperature, 90 degrees. We pick the cooling capacity, that defines the size of the condenser.
What? I know, okay. I just want to touch a couple of items on the APG. While I was walking around here, I asked a couple of people, what do you think of the APG? And it was kind of like a blank look. I said, how would you sell this? We are in the selling business, and I think it's important that we know what we have in the APG. Why don't we just briefly summarize the features of the APG and what it means to us in terms of the selling tool. Number one, APG is a single gas system. Anybody know why this would be an advantage over any other system, including our own in the field? Can anyone tell me? Come back up here, Thomas. Longer life of what?
Longer compound life.
Okay, single gas. Okay, that's good. What else do we know about it? Dennis?
The aircraft industry prefers the argon, especially if it's in a single gas.
Okay, so we got single gas and it's a preferable gas in terms of argon. What else?
Jones Schlesinger, 792.
You maintain the KW that you are right there.
Okay, now we're starting to get to some important things. We're maintaining the KW. What do you mean by that, Roy?
You maintain the heat level that you want to generate the melting power.
Okay, if we go back to any system, whether it's combustion, whether it's plasma, whether it's arc, the key to all the systems are you have to have enough BTUs to melt a prescribed quantity of material, right? BTUs and pounds per hour have to match. Okay, I'm going to continue on with this. Let's talk another thing. You said control KW. Has anyone ever addressed the fact that this system is closed loop? Nobody? Why is it closed loop?
Because you got the variable electrode.
Okay, what have your customers been telling you for the last 5 years? You guys have been screaming and yelling, what are we going to do? Can we close loop this process? We've done it. We give you a single gas, we give you a preferable gas, and now we close loop that parameter, voltage, which nobody can close loop it at this stage of the game. Why? What does a customer have to do in order to maintain voltage? What kind of secondary gases do we have? Great, hydrogen and helium. Okay, what happens when we put hydrogen in? Makes the flame hotter, but what happens to our nozzle life? Okay. What does press say? Anything over 10 or 15% is totally unacceptable. What happens as the nozzle life starts to go down? The customer has downtime. There's always a chance of blowing a gun. If he has any water leakage in it, we're dead. Right? Okay, let's now go back. What do we have? Single gas, argon, closed loop. 3 big items right off the bat. Let's go to some of the other things. And it's controllable. We don't have to touch it. The electrode keeps adjusting itself as the nozzle or the electrode wears. Do you think that's a significant feature that we should be thinking about selling to our customers?
Question.
You got it.
This is Type 2 AJ air blast core. This new device replaces the AJ that I guess we've been selling for the last 1,000,000 years. There's a few little details I'll tell you about on this device, and they're all very nice, but the real major important factor is you turn this thing on, it does a job better than the old one, it does not make any noise. You get some sophisticated customers, they get all bent out of shape because they read the OSHA requirements, like in Metco, and what that means is the truck shows up here last week to give all the employees a hearing test. Those are the people who work in the lab, of course. The reason why is because they're exposed to noise levels of 85 dBA or more on the job. This device runs around 70 some odd dBA. The AJ, that annoying thing that we all know about, runs in excess of 90 dBA. So on that and that alone, you can sell the product. As far as the capacity of this device is concerned, it consumes a little bit more compressed air than the old one. It, however, delivers more velocity coming out at the end. It delivers more cubic feet per minute. Some of the more detailed features on the device is that we sell it with a 5-foot hose as well as a 15-foot hose. The 15-foot hose attaches between here and the center spigot on the 4A air control. The small aluminum block is a convenience. The customer can screw it down to a spray booth so we can operate this valve with one hand. The reason we put the valve in remotely from the unit is we had some people complaining that the operator sprays on the old valve, jams it up, it doesn't work anymore. The small 5-foot hose as well as the 15-foot hose are interchangeable, so you can put the 5-foot or the 15-foot between this and this. The principle of operation on the old AJ air cooler is there's a single orifice, a single spigot in the middle, and as the air comes out, it creates an awful lot of turbulence, and that's what causes the noise. With this device, it works on a completely different principle known as the Coanda effect. What that means is we have a central cavity in here. The air is introduced through this thing. It swirls around and comes out through a small 2/1000 gap. The air then follows the metal around and aspirates in the ambient air. As far as the customer is concerned, if he uses the 4A air control, there shouldn't be any reason why this thing gets clogged up. But if it should, he simply removes this thing, takes it out and cleans it. If he destroys the shim, fine, there's replacement parts. We're learning a little bit as we go along, and to ensure the fact that he can get this thing out after a few months of service, we put an O-ring in the back to keep the metal dust out. It's best to appreciate this thing when you actually see it operate. We'll be going out in the lab in a few minutes. I will say that the arm that this mounts on is the same as the old arm we've been using a long, long time. We investigated various other schemes, but unfortunately those schemes are either impractical or very costly. It doesn't make much sense to sell something, to design something that you can't sell. Are there any questions? Okay, now we'll go into the 4AC air cleaner. The 4AC air cleaner replaces the 3AC air cleaner that again has been in the product line for many years. Some years ago, the 3AC air cleaner had a reasonable cost to it, and we were able to sell quite a few. Unfortunately, in the last 10 years or so, the price of that device has increased to the point where it's very difficult to sell. So what we did is we looked at various vendors. We came up with a custom-built device from a new vendor who incidentally bought out the old product line from Silas. And we now have this 3AC air cleaner, which for all practical purposes does the same job as the old one, except the cost to manufacture the new one is less than half the cost of the old one. But of course, I don't know what this is going to mean in the selling price. That's up to Andy. But there's been a very significant reduction in the cost. As far as the cartridge is concerned, the new cartridge is completely different than the old one in construction, although it does perform the same function. No longer do you have to drag the old cartridge out of the 3AC, unravel the turnbuckles and clean the filter elements. What happens is it's the same thing as on your automobile. You open up the top, take the cartridge away, out and throw it away, you put a brand new one in, and no fussing around with cleaning, etc. To remind everyone about the capacity, it is good enough to handle up to 6 combustion guns. Talking in the order of 300 cubic feet of air per minute at pressures up to 100 psi, which is the normal air compressor pressure available in this country. Proof pressure is 165 psi with a maximum temperature
of 150 degrees, so there's no problem there.
The cartridge cheaper or more?
We'll put that out. And what we have in this new device is going up through the middle of the cartridge. There's a tube, and all the air goes into there and then goes sideways. All right? It doesn't go through the long length of the cartridge. There's what is known as a coalescer filter on the inside, another one on the outside, and the interface is all filled up with charcoal. Another thing which increased the cost of the old one primarily because of its unreliability was the filter on the outside. That was a catch-as-mitt to catch the charcoal in case the cartridge ever failed.
Right.
On this new device, we don't need that anymore because the inner wall as well as the outer wall of this cartridge is about a half-inch thick, epoxy glued together into rabbited areas. So even if the epoxy should fail, the thing's not going to come apart. To give you some idea of the performance, we have 6 of these things in here now. We took one of them, put them on the airline with a quarter-turn valve, and with either the inlet or the outlet blocked, we opened up these valves real quick to shock the thing, and we could not destroy the cartridge. So we then filled the thing up with water, put the cartridge in it, and left it there for a week. At the end of the week, we drained all the water out, repeated the test, and the cartridge remained intact. So I think we have a pretty good design there. There shouldn't be any problems with it. That's about it. If you wish to have no more questions, we can walk out into the lab. We can demonstrate the 2HA. I can show you the 4AC here.
Okay, what I'm going to be speaking on is this specially designed fixture for spraying the inside diameters of JT9 burner cans. For those of you that don't know what a JT9 burner can is, it's the combustion chamber that's used on the Pratt & Whitney engines that are in most 747s. It's a can that has, I guess about a 2 or 3 foot diameter. You'll see it at the demo area once we go out there for our demonstration. During routine maintenance of these combustion chambers, they have to strip them down and respray them. Okay, the spraying operation is done in 4 phases. There's a preheat pass, and then 3 passes with applying 450 bond coat, and then 6 passes for 421 Cermet, and then a top coat which consists of 9 passes of 210NS. The total thickness of the coating at the end ends up being about 19 thousandths. Each pass applies approximately 1/1000th of coating. The operation takes a little over 3.5 hours to complete, so it gets pretty hot down inside the chamber. This fixture, coupled with an AR1000 robot, gives consistency that never before was attainable. Prior to this fixture, most airlines were coating the chambers manually. It's very technique-dependent operation. The tolerance spread on the total thickness of the chamber coating is about 4 thousandths. If my memory serves me right, the Pratt & Whitney Spec 261 calls for 17 to 21 thousandths. We're putting down 19 thousandths consistently, plus or minus 5/10. And we can do this day in and day out with this fixture coupled to the robot. Right now, Qantas Airlines is the only airline that has a fixture of this sort coupled to our AR1000 robot. Rich Lambert and myself installed this system for Qantas, and we sprayed a final burner can. When we finished spraying the can, Qantas personnel commented, which was pretty nice for us, that it was the best spray coating they've ever seen on a JT9 burner can, including the ones they get from Pratt & Whitney. Now, we were at Qantas for a couple of weeks, and we befriended supervision. So one time on the side, I got the supervisor of the plastic spray department, Peter Barbarissis, and I said, Peter, you were spraying these manually. How did you possibly maintain the tolerances that the Pratt & Whitney spec calls out for? So he said, well, Bill, he says, we hold very, very close tolerances. We hold plus or minus %.
I think the point to be made is that they were doing the best they could with the equipment they had, manual process, and no way can they compete with this robot. The fixture itself is built around a standard basically standard 3 MB gun. The front and rear gun bodies are standard. The only modification is to the insulator. I had to extend the insulator inlet for plasma gas with a piece of vest belt. I did that because I was afraid of arcing between the front and rear gun bodies during the spray operation. Other than that, they're all standard catalog parts in the gun itself. Then we have a bracket that's a little bit longer than the total depth of the burner can. This was done for two reasons. Number one, so we can get down inside the burner can to spray the areas we had to spray. And number two, that we could extend the fitting inlet outside the heat zone of the spray operation. As I said before, it gets very hot down in the burner can, and it would tend to melt hoses if we didn't do that. The positive and negative power lines are extended, this is pretty heavy by the way, are extended by brass tubing. And the plasma gas line and the two powder feed lines are extended with stainless steel. Also, we incorporated a air cooling system on the fixture. The fitting here with compressed air enters, and there's two stainless steel tubes going down to cool the gun head. One in the back to cool the rear gun body, and one in the front to cool the insulator. The bracket is quite rigid. It's made out of steel, and there's no vibration or deflection during the spray operation. Also, we have a 5-piece insulator on the back, which acts as a gun mount and an insulator for insulating the plasma spray from the robot. Other than that, that's basically it. Is there any questions?
Pass it around. This part of the agenda is briefly to discuss the hardware and the powders for spraying zinc and Babbitt powder. Marty Hacker will present the hardware concerned with this, and I'll just, as I said before, briefly discuss the powder aspect. Spraying with Babbitt powder and or zinc powder has some distinct advantages over the wire composition. Babbitt powder, which will be called Metco 50, is similar in composition to our straight Babbitt 8 wire. Some of the advantages it has over the wire is that it is low smoking or fuming. The same thing is true for zinc. As a matter of fact, with zinc, it's even more important because we reduce fuming with zinc, we reduce the incidence of zinc chill, which many operators have been prone to when wire spraying zinc. Spraying with the powder gun affords the operator greater comfort in terms of the gun is easier to control, there's no wire drag, and it's low noise. And the same properties are attributable to the zinc powder. The zinc powder will be designated Metco 53. Now, I put up this chart, and I basically asked that you look mainly at the spray rate and deposit efficiency and the bond strength. The cost per pound deposited was based on work done approximately a year ago, and the tin market is a very volatile market and changes daily. So what I'm really showing here is that spraying Babbitt powder in terms of pounds of material deposited is better than with the wire, and that the bond strengths are very good. I might say the same thing about the zinc. I don't have a chart giving this information for the zinc, but there is a tech report out on the zinc and Babbitt, and I don't know if everyone has received it.
Tomorrow.
Tomorrow? Okay. And it will show that we can spray the zinc at 65 pounds an hour with an 85% deposit efficiency, which is better than we can do with the wire in any mold and any size of the wire. And once again, the cost of applying the Babbitt or the zinc, we feel is comparable to putting it down with the wire. The bond strength of a zinc spray coating runs about 3,800 psi, which is equivalent to arc sprayed zinc and considerably higher than combustion sprayed zinc. Now these are some microstructures of sprayed Babbitt coating, and the thing that I'd like to point out so that everyone can see is that with a spray Babbitt powder coating, we have a much more uniform distribution of the antimony as opposed to the combustion or the arc. And the antimony is these little bright slips that you see throughout the coating. So as far as coating microstructure is concerned, the Babbitt shows an advantage. Now with respect to zinc is basically used for corrosion. And we've sprayed the powder zinc coatings, we put them in accelerated corrosion, and we find that there's no difference with the wire sprayed zinc. I'd like to turn this over now to Marty, who'll discuss some of the hardware aspects.
There are several modifications that have to be done to achieve this with a standard 6P and 4MP powder feeder. One, in order to achieve the high spray rates, we need a deep pickup. At first glance, it looks similar to an A pickup, but the through hole is much larger and the side holes are much larger. I believe the through hole is about 1/8 of an inch and the side holes are about 70 thousandths versus approximately 60,000 through hole and 43,000 side holes. This is in order to achieve up to 100 pounds an hour with Babbitt and approximately 65 pounds with zinc. Also, the hopper plug on the hoppers would have to be replaced. This is merely hogged out to allow greater area down bottom so the volume of powder falling down can be picked up by the pickup. This is sold as is and would incorporate disassembling the hopper, knocking out the bottom, exchanging hardware, and putting it back on. That would be all that would be required for a 4MP. As far as the gun goes, a simple air cap change and a nozzle change. Because of the low melting point of the material, we had to rechannel the air going through the nozzle and through the gun to produce an envelope of air between the flame and the powder. Under normal circumstances, you would have powder coming out of the center of your nozzle, your flame, and then air cooling or impinging. This was not adequate enough to spray these low melting point materials. So we had to drill both radially and axially. So we now force air between the powder and the flame. The flame then in turn heats the air, creating a superheated air, which then in turn melts the powder. This will be vividly demonstrated later on. And the nozzle and the air cap incorporates an O-ring which forces air into the holes in the nozzle. One other thing on the powder feeder, you'll have to replace the little filter on the bottom of the hopper. And that's all there is for hardware changes.
And I'm a temporary employee here at Metco. I've been for the last couple of weeks. Normally I'm stationed out of San Diego and I own a small shop in San Diego. We have built these units and supplied these units with Metco type equipment on the inside. Now we're presenting them to you as products for your potential customers. The units are a containerized mobile system. Containerized mobile system is a concept which we're allowing you to give your customers a complete turnkey facility. Set these units down in place. You have single source of power, single source of air. You have a complete facility to do your abrasive blasting as well as your spraying. Now, I want you to keep in mind that when I say turnkey, I mean just totally turnkey. We can also supply generators if necessary and or compressors, which gives you full turnkey operation where you don't have to have your customer supply a thing. The nice thing about it, a little history about how many units we have had out and where they've been, is we have 36 sets of these units, an A and a B, we call them A and Bs, 36 sets of these units in and around the United States as well as in Japan, in the Philippines, and in Guam. The units have been primarily used for the United States Navy. The Navy is using ship spores to either do corrosion control and or metal buildup. So we will put a 10E, 12E wire guns inside, or 5P, 6P powder guns inside. Along with that, this is the first unit that we came up with a conception to put a plasma system inside. In this particular unit, we have an plasma system inside. As well as these two units, the other type of units that we built are a machine shop to go along with this, a valve repair facility, a complete facility, where you have a third or a fourth container, one housing a lathe with a drill press and a milling machine, hydro test machine, as well as anything that they need to repair valves. So it puts it alongside a dockside or puts it aboard ship, and now these people have total capability of doing those particular parts. As far as the options on these pieces of equipment are involved, you can put anything you want inside of it. Your customer needs it double wide, he needs it triple wide, he needs it twice as long. All we're going to do is kind of build a suit. You're going to determine what his needs are, or what their needs are, and you're going to tell us, and we're going to end up putting the right equipment in and designing it for that particular customer. There are some standard models available. It would be a lot easier to obviously build standard models, but I don't want that to be a limitation. And if it is a limitation, I don't want to limit you on the potential of a potential customer, because he might need this or he might need that, and the standard units wouldn't supply it, so he says, well, he's going to do something else. Where we've seen a lot of interest is we've seen a lot of interest in R&D facilities, where they'll need to do abrasive blasting and plasma spraying or some other type of spraying for development of future coatings, especially in Star Wars applications. We've seen a lot of companies who have interest because they're working on sensitive parts. They don't want to send those parts out to a job shop. They want to keep that research and development in-house. A lot of companies have done that. I know it's late in the day, and I know that you've been through a lot of presentations already. I'll try to be as brief as possible. If during my presentation you have any questions, please feel free to ask. I'm going to describe the equipment, go through it, tell you how the things are manufactured. By the way, these units are designed to operate outside as well as inside. They've been wire-sprayed aluminum coated on the outside and then subsequently painted. The color codes on them are, back up to our customer's needs. If he wants them pink, we'll paint them pink. But this is the standard color that both Metco and us decided on for these units. The units are comprised of this backstation here, which houses the single source supply of power. One single source of power comes into the unit, in this particular case 440 volts, 175 amp service. Then distribution is taking place from this entire distribution panel. So everything is all approved as far as electrical kind of connection, and there's an umbilical cord that runs from this container to the other container, supplying you with power to the other container. The air supply comes in on the back of this particular container, goes through this unit, which is a refrigerated air dryer, which is a regenerative air dryer. The regenerative air drying system, in my experience, provides you with two things. One, very low maintenance. Secondly, a most effective system of cleaning and drying your air for both abrasive blasting as well as spraying. So for those of you who are not familiar with the regenerative system, if you want to talk to me about it later, you can. The air comes in, it goes through an air-cooled apple cooler, it goes into a moisture separator, from there it goes into an oil fluorescent filter. It has a pressure differential gauge on it, which tells you immediately when the filter is dirty, time to change the filter. From there it goes into one of two tanks, which is, these tanks are filled with an activated alumina, takes and absorbs the moisture or the oils out of the air. It operates off of one of the other tanks while one tank is in operation, the other tank is being purged or it's being backflushed, cleaning out the other tank. Then both of them pressurize and they can start depressurizing one and operating off of the other. For 7 minutes, every 7 minutes it goes through this cycle and cleans and dries your air. Then from there it goes into a final particulate filter and then through your distribution. The two pumps that we see on the bottom of the floor, the pump on the right is for the water wash section, the pump on the left is for a closed loop system for the heat exchanger for your plasma. We're utilizing the water wash section itself as a cooling tower. The cooling tower provides you with air by the water wash, thereby cooling down that water. And we're sucking water out of the bottom of the water wash tank, pumping it to the heat exchanger back into the top of the tank. It has a filter on the outgoing line, again, pressure differential gauges to pick up any particulate matter in the water. If we want to move around to the right, we'll take a look at the working portion of things. Container. The weight of this unit is 17,000 pounds, fully loaded with all the equipment inside. The concept of this particular container obviously limits you in a certain amount of size parts that you can do. We put a tilting turntable in as well as a vertical traverse device. I'm sure that you've all seen them before. The MM system, which in my opinion is a great piece of equipment. It's I'm a 3M nut, and I think that this is going to far sell the 3M systems. Water wash section in here, we're pumping 13,600 CFM of air through an air inlet at the top. If you look up on top of the unit, you'll see a silencer. That silencer is stored for transportation inside the blast room, and then is subsequently set up on top for operation. What that does, it provides you with silenced air for the incoming air into the booth. So we're pulling 13,600 CFM. The base velocity of the water wash is about 400 feet of free air per minute, which inside this room, if whoever wants to come inside it while the unit is running, it's extremely comfortable for the operator. The operator is extremely comfortable at all times. We tested the unit at 100 degrees, it was right around 96 to 100 degrees Fahrenheit, and humidity was in the 80s, in the high 80s. What about the reverse? Okay, for heat, what you do is you put heating coils on the inlet. There's a bracket that you put heating coils on the air inlet. Now, it's not going to get it 70 degrees, but it's surely not going to be freezing cold either. And I'm not exactly sure what the temperature is going to be, but definitely it'll bring it up where it'll be a comfortable level.
Are those electrical equipment or electrical heating in the inlet there?
Yes. Electrical coils go in front of the air intakes. The whole room has been 4 inches of sound insulation on the roof as well as the walls. We can run this plasma all day long. You can stand right outside. The dB level outside is about 82 to 85. You can hear the whistle of a plasma, just like you would see in the rest of the booths around. So sound attenuation inside this booth is extremely good. The power supply or the power cables come into a gutter up front, go into a distribution panel, which is a hinged distribution panel for easy access and for easy repairs if you have to get to it. From there, then all your umbilical cords run to the power supply as well as the heat exchanger. Also, water comes in on your bottom gutter as well. The controls, we just put the controls on a little roll-in, roll-out rack for ease in operation, as well as being able to fill up the heat exchanger. The back panel of this room, and I'll explain this room in a minute, but the back panel of this room lifts up so that you can forklift out both the heat exchanger and or the power supply if necessary for repairs. This room is an expandable room, meaning that we can pull it in for transportation, roll it back out for operation. The whole concept is to keep the thing within 40 feet for transportation purposes. Again, everything else is done bolts and standard fittings. Everything that you see in this unit is an off-the-shelf item. There's nothing that is, unusually manufactured or whatever. I mean, you can go to any kind of hardware store and purchase it. With the units, you get what I call a Dick and Jane instruction manual. And it is very simply done. We've designed it for the Navy's use, and the Navy has accepted it worldwide, and it's become a very good instruction manual as far as operation, maintenance, spare parts, and whatever. That all comes in. The controls back here, one control is for the after cooler and the air drying system, which the light comes on obviously when the system is activated. The second control is for your water wash. When the water wash booth comes on, there's a flashing light behind the door that flashes, warning people don't come in this room because there's a cloud of light or noise levels that are unacceptable. Are there any questions?
What's that panel over there?
This panel?
Yeah.
Turn off the camera a minute, I'll explain. Both the abrasive blasting, or you need some way to prepare your parts. This happens to be a full floor recovery system, which is probably a little bit more sophisticated than what some people are used to. My personal opinion is that a walk-in booth is a lot easier to control an operator. He has a lot more flexibility on how he's blasting a part than he has with a type of cabinet that he has to stick his hands in. But don't limit that in your thinking. As well as this walk-in booth, there could be cabinets inside here as well. So don't, just because we have a walk-in booth, if somebody wants a cabinet, we can put a cabinet in. The type of cabinets that we would use are cabinets that have a full recovery system with it. So the cabinet would be a pressure-type cabinet with a pressure pot, with a not a cyclone separator, but with an abrasive screen separator, as well as a dust collector separately. This particular unit is, like I said earlier, is an air-swept floor, so there's no moving parts. Now, for those of you who are involved with abrasive blasting and mechanical floors and aluminum oxide, because primarily that's what we're using inside these, it's a real pain in the neck to try to get an adequate floor that is a mechanical type floor that won't wear out and you have a lot of maintenance problems. But we've gone through very many pains and strains to try to develop correct airflow to meet the requirements of moving 20 grit aluminum oxide through this room. We've finally done it, and we finally, it's gone through, like I said, a number of different strains to get there, but now we've got an effective unit that's run for years and years in service, and it's actually been sailor-proof. We've designed it now where I don't care how much the sailors screw up, there's escape hatches everywhere, they can fix it. So no matter what operator gets in here, no matter what he does, there's still a method of it being able to fix this room. There is two pots in back of this room, and primarily for this particular application, you can utilize the two pots for two different things. One is to use two different grits in them. One being, a 60-80, a 20-40, or whatever, and then have the capability of being able to switch back and forth. For corrosion control, what they utilize two pots is one for stripping your parts. So now you have all your rust, all your paint, and everything else isolated into one pot. And you continue to use that to strip your existing components. And then by just a slide gate in the back, you switch over to your virgin aluminum oxide or your good grit, and then you anchor tooth or sweep blast for your final preparation for spring. So the abrasive is conveyed through the floor, and then it comes into the top of the cyclone separator, and if those of you are familiar with a cyclone separator, it removes the dust from the grit. The dust comes into this bag house. This bag house has a 4-to-1 air-to-cloth ratio, which meets all EPA requirements in California, so therefore it would meet every other state's EPA requirements. It has an automatic shaker bag on the bottom, which means that periodically during the course of the day or cycling, the man operates the automatic shakers. It shakes the dust down to the bottom of the drawers. And on the back side of the unit, we supply a little vacuum. There's a dust drawer that opens up and he vacuums it out. As far as operator safety on the inside, there's the air system that supplying that unit. The spray container goes through the drying system, and that spray container is fed over into this blast container, and then we go through a separate drying system or a separate air breather filter for the operator. Along with that, we put a CO2 monitor on the wall because you never know where the problems of CO2 are going to come into as far as getting into the breathing air. So it's an audible alarm in this room. Inside the work area itself, there's a visual lights that flash on and off, that warns the operator that there could be or potentially be some dangerous air that he would be breathing. Okay. We'll move on to the front. The blast room functions in this mode. Air is being sucked in from the blower that you saw in the back room through this opening up here in the top. It comes down through these vents on either side and does two things. It conveys the abrasive as well as gives 5 air changes a minute within this room. So whatever the volume of this room is, we're providing 5 air changes a minute. This gives the operator more than enough visibility, and also, secondly, it provides enough airflow to convey the abrasive through the floor and then dump back down into the pot. The way you charge the room is you turn the blower on, you bring your grit on a pallet, you throw it on the floor. It automatically gets sucked back up and dumped into the pot. When you finally expend that grit, or it breaks down far enough where you're no longer achieving your proper profiles or whatever, there is an exhaust hose which takes the place of one of these blast hoses, and it's a longer one. You run it out into a 55-gallon drum, and you just turn on your blast generator without any air pressure, and you deposit all the you use abrasive into the room. I mean into the 55-gallon drum. All the walls are rubber lined for ease and replacement. So in case you don't want to be blasting through, it's difficult to replace the steel walls. It's a lot easier to replace the rubber on the wall. It comes with all the safety, dead man switches for your abrasive blast. It comes with 2 different size hoses. These on the walls you'll see are large production type hoses. There's a smaller one in the back which is called a whip hose. We call it a whip hose. It's for little small parts or little IDs or whatever. Safety equipment, everything is lit. 2 little lights up there in the top little corner for your safety lights. Every possible area in front of this booth and on the back side there's cleanouts where in case something happens you can open up these cleanouts and get airflow. One of the basic problems that we found is that operators won't turn on the blower before they start dumping in their grit. So now they got this thing filled with grit and no way to get any air passed by this grit. So there's an escape hatch on the inside where you open it up, it allows airflow through it, and it will pick up the abrasive and move it through. That's basically it. If there's any questions, I'll be glad to answer them.
Hello, my name is Ed Gianella, and I'll be talking to you about the 4MP800 powder feed rate meter. The 4MP800 feed rate meter was designed to save our customers operating expenses. I'm sure you're all familiar with the manual method of taking feed rates, which involves spraying material into a container and timing it with a stopwatch and basically weighing it to get your grams per minute of powder flow. This method has been used for years, and it is good to set up the feeder with, except that you do waste a lot of material while you're setting up the powder feeder. In addition to that, if your feed rate changes while you're spraying a part, you'll also waste material due to changes in the deposit efficiency. Also, you don't know if your feed rate changes while you're spraying a part. You may wind up rejecting a part here and there because of out-of-tolerance coating thicknesses and hardness and so forth. With the automatic method, which represents the 4MP800, the hopper is continuously weighed over time, as indicated on the chart. This will give you your, and by this method, this will give you your gram rate. Okay, now since you can see the spray rate while you're spraying a part, you can make adjustments, and all other things being equal, you'll wind up with more uniform, predictable coating thickness on every part you spray. It will also give you better process supervision, because your foreman can now walk through the shop and at a glance tell if the operator is spraying at the proper rate. Also, if you're spraying a long job and you see the rate vary a bit, you can make an adjustment using the control on the 4MP and wait a period of time and see that your adjustment was correct. Okay? The product features. As I pointed out before, the hopper is continuously weighed, and the hopper weight loss over time, as sensed by the instrument, gives you your grams per minute. All right, so it's a direct method. The amount of powder you can put in a hopper is limited only by the hopper volume. The system was designed for a production hopper, and it can take its maximum weight capacity is such that it can take a production hopper full of tungsten carbide, which is approximately 75 pounds. The unit will give you a real-time continuous indication of the feed rate in either pounds per hour or grams per minute, and that can be selected by a toggle switch on the back, and it will tell you on the front panel which unit you're in. Alright, that is the only adjustment on that unit. There are no other calibration or adjustments or operator training required whatsoever. Everything else is automatic. The precision on the display in the pounds per hour scale is 0.1 pounds per hour. On the grams per minute scale, it'll tell you what the feed rate is to the nearest gram per minute. Okay. The device is designed so that when the powder flow is steady, it will give you a 1 minute average, just the way you're used to doing or seeing now when you spray material into the bottle for 1 minute. However, when the feed rate is varying during startup, shutdown, if you run out of powder, for example, the averaging period shrinks to a much smaller time period, on the order of 3 or 4 seconds. What this does is it allows you to see changes much more quickly than a straight 1 minute average would tend to show you. All right. Now, I have Metco 201B in the hopper, set up to feed at approximately 7 pounds an hour. When I turn the unit on, what you'll see is the display will blank out, a light will come on to indicate that the feed rate is stabilizing, and when the ready light comes on, the spray rate will come up on the display. So 201 in the hopper, set up to feed at approximately 7 pounds an hour. When I depress the spray button to turn the unit on, what you will see is the display will blank out, a light will come on to indicate that the unit is pressurizing. After about 5 seconds later, a second light will come on to indicate that the powder feed rate is beginning to stabilize, and approximately 10 to 15 seconds after that, the ready light will come on. At that point, you will see your gram rate on the display, and from then on in, it will be continuously updated to reflect the amount of material actually coming out of the feeder. It's also set up in the pounds per hour mode. The feed rate did come up to approximately 7 pounds an hour. Online adjustments can be made. For example, to half the rate, you would approximately have the hopper pressure. We're at approximately 70 inches of water.
turn it down to around 30 or 35. Now there'll be about a 5 to 10 second delay before this number starts changing. And we should come down to about 3.5 to 4 pounds per hour. Recommended procedure to set your feed rate using this device for initial powder feeder setup. For example, if you wanted 7 pounds per hour, you would go to your 4MP parameter book, set the feeder up in accordance with the parameters, which will give you the approximate value of rate that you want. Then you would turn the unit on and wait 15 to 20 seconds to get the displayed value. After you see what the feed rate is, you would then make an adjustment. In this case, I'm going to turn the hopper pressure down because it's too high. Turn the feeder back off again, and then turn it on to see the new value. The reason this feeder is set up, or we're setting up the feeder this way, is because the feed rate meter will respond to large changes in feed rate more quickly than to slow changes. That being the case, the rate will come up into its final value more quickly by turning the feeder on and off again. Okay, now if you're spraying a long job, and you obviously cannot turn the feeder on and off, what you would do is just make a small adjustment, small adjustment at a time, and then wait approximately a minute or so to see the effect of your adjustment. Eventually it will stabilize at the new value. That concludes our presentation and demonstration on the 4MP 800 powder feeder.
Marty Hacker, I'd like to demonstrate the zinc babbitt hardware for you and the type of coating that it will produce. As previously discussed in the meeting, I showed you the hardware, nozzle, air cap, and some modifications to the feeder. When I light this, I will demonstrate a slight adjustment in the fuel gas will produce a brighter flame or less brighter, in turn produce smoke or no smoke. You may have to tailor your parameters slightly to meet your needs. The parameters given is for overall coating application. When I start to spray the panel, at first it will go down like any other coating. Once the substrate comes up to temperature, you will see the material tend to shine. Knowing the babbitt is a critical point at which to spray at, you would not want to go any more than 375, 400 degrees, otherwise you'll get dripping or melting, which I will demonstrate. 100 pounds per hour. As you see, when the panel got hot and I traveled too slow, it literally ran and dripped off. So there will be some technique, there will be technique in spraying Babbitt, as it is with the wire gun. I will now change over and spray zinc at about 55, 60 pounds per hour. Kill it. Still running? Yeah.
My name is Andy Walker. I'm with Metco Systems Engineering Group. This morning I'd like to tell you a little bit about Metco's LR500 turntable. The LR500 is a 5-axis turntable designed specifically to be directly interfaced with the Aero 1000 robot. It can easily be modified to be interfaced with just about any other piece of Metco handling equipment. It consists of 5 axes in motion. I'd like to briefly describe them to you right now. First axis, or A, is the spindle faceplate rotation. With this 40-inch faceplate installed as you see it, the axis will go from 0 to 150 RPM and multiples of 2 RPM. With that faceplate removed and the 12-inch faceplate installed, the axis will do 500 RPM. When the spindle is used as an axis, it can be programmed to index around a circle in multiples of 2 degrees, and the dwell time is freely programmable at each station. The next axis, or B, is the tilting axis of the turntable. The table has 160 degrees of movement plus or minus of 0, and horizontal would be the 0 position. In the horizontal position, it will support 770 pounds. The vertical position will support 550 pounds. On this model of the turntable, this axis is driven by a motor and a gearbox, but as an option, it is available to be numerically controlled. Third axis, or C, is the height adjustment of the turntable. The turntable is adjustable from a height of 23 inches from the floor up to a height of 57 inches. Again, on this model, it's driven by a motor and a gearbox, but as an option is available to be numerically controlled. The fourth axis, or D, is the swiveling motion around the tower. As you can see, it's quite easy to move D. The operator will move it to the desired position, or a hydraulic clanking system holds it securely in place. Clamps released and be moved anywhere you want. The last axis D is the horizontal movement along the floor. The turntable allows for 80 inches of movement in or out. Again, it's quite easy to move. The operator would move it to its desired position, and the hydraulic clamps again hold it securely in place. The system is manually moved using this operator's jaw box. We have up, down, tilt left, tilt right. Base plate rotation, have the spindle, and two hydraulic releases for the manual action. That electrical cabinet in the corner is the housing for the computer and all the electronics for the machine. It's fully expandable to accept the other two optional NC axes. All the programming and automatic control is done on this operator's control box. The system comes pre-programmed with 57 speed routines. There are 83 remaining memory positions available for custom user programs. That's about it. We want to finish. I'll show you.
I'm the chief of and I'm with the System Engineering Group. And what you're looking at here is a six-axis gantry system which we designed and developed for Pratt Whitney Incorporated. The unit you're looking at stands about 19 feet wide. The y-axis has maximum travel. This is to allow a 60-inch growth on the vertical. The gantry itself has 4 axes of movement: horizontal, vertical, roll of the gun, and pitch. I'm using a heat pendant right now to move each of the axes in the jaw mode. The turntable portion of the system incorporates 2 axes, tilt and rotation. rotating axis can also be programmed as a spindle. The horizontal and vertical axes will operate at speeds up to 600 inches per minute. And all rotary axes will operate up to 10,800 degrees per minute. Except the tilt on the turntable. That speed is about 4,000 degrees per minute. We also have a track system. The track is powered by a DC motor and driven by a urethane stainless steel reinforced belt. The same belt is used on the horizontal and vertical axis. The urethane belt is impervious to the flame spray environment. The turntable is capable of changing its height with manual controls. The height on the turntable is adjustable from 24 inches to 39 inches. The track can also be operated in the manual mode for setup. Both the track and the turntable elevation are controlled by an SCR located in this control box. The gantry robot is controlled by an Allen Bradley 8200 AT. It is the latest addition to the 8200 series and is capable of operating up to 12 axes in motion. In this case, we're using it for 6 axes. Incorporated several software features into the 8200 to enhance its capability to control the federal spray process. You can see some of these here on the screen. We have an ATCS system status, which is a communication link with the Metco ATCS system. We can control startup, shutdown of the gun, advancing through all the different sequences on the ATCS. And everything that's occurring on the ATCS will come up on this screen as it occurs. So the operator can run the entire process watching the one screen. You'll notice from the conceptual drawing we have here that the Allen Bradley 8200 and Metco ATCS will be in control room right next to the gantry robot. It is an crucible room with access to the gantry through a service door on the group. Some of the other features on the 8200 are the machine status features. From this screen we can see whether or not the remote pendant is active, whether or not the doors of the spray cell are open or closed, status of the exhaust system, and status of the turntable, which are all controlled by Allen Bradley 8200. We also have status of the counterbalance for the vertical axis. In addition to that, we've got control of 3 cooler groups, which you can see up in the corner here. We can pull these up from the program, or they can be controlled by an optical temperature sensor. In addition, we've added 12 auxiliary functions, which your customer can use as they see fit to run auxiliary functions. The exhaust fan you see here is provided with master panels, so the airflow through the room can be better controlled. This exhaust rating will be attached to a 12,000 CFM wet electric type exhaust.
Working with the new market development people, is to have a culmination of a system sale using the latest ATCS technology. This morning, we would like to discuss 5 new powders. They will be Metco 700, which is a nickel-based amorphous alloy coating, and the theory behind Metco 205NS, a new thermal barrier coating. They will be discussed by Dr. Ranga Swami, better known to all of us as Ranga. Metco 750, a new nickel hard surfacing alloy, and Metco 480NS, a new fully alloyed nickel aluminum self-bonding powder by Ed Novinsky, and Metco 449T, a new high carbon steel composite powder, and the commercialization of the thermal barrier 205NS powder by Mitchell Dorfman. Now, in addition to these 3 senior applications engineers, The applications engineering section is rounded out by Hildy Florence. You all know Hildy. She's our expert in many areas, including that very esoteric one in parameter development. And Joe Mercurio, who handles all our internal and external specifications, our material safety data sheet, the general product maintenance requirements, and of course your special product requests all go through Joe, and anything else that I can throw at him. In addition to these people, I want to take this opportunity to thank all of our technicians. As you know, without these technicians, nothing really gets done. And a vote of thanks goes to Tony Della Rosa, Mike Dopper, John Vanetti, John Wissick, and Jim Wagner. At this time, I'd like to call up Rhonda to start the discussions on Metco 700, followed by the theory on the development of the 205NS. Rhonda?
Light? Okay. Morning, everybody. We're going to talk about the Metco 700, which is an alloy that some of you have heard about, some of you have used it, some of you have field tested it, and some of you have heard about it as CE2325. One of the things is that Metco 700 has the unique distinction of being the first proprietary Metco alloy in about 50 plus years. You know, we have made a lot of money making composites, blends, and with increased competition and with increased sophistication of customers, we've been moving away to alloys. I think this is one of the first ones. I think it's a good one. Not only that, this alloy is going to launch us into a new and exciting area of amorphous coating technology. I think that's going to be helpful in not only in getting some good properties, but also as a marketing tool. What I'd like to talk today is about, give you some idea of the unique features of this alloy, the coating produced from this, and then discuss some of the applications where I see this going in and where I see that this should not be tried. First slide, please. Metco 700 is essentially a nickel-based alloy. We make it by atomizing from the melt. It's a nickel-based alloy. It's got a variety of alloy elements like chromium, molybdenum, tungsten, boron, carbon, copper. It's a complex alloy. For those of you interested in exact chemistry, we can provide it. But the unique thing is that if you plasma spray this alloy, you get an amorphous coating. Now, what is an amorphous coating? An amorphous coating is a coating which doesn't have the crystalline structure. I think a lot of people who ask me this question at other times, I give a small little example. Imagine, if you will, a concert hall. The people are sitting in assigned seats. They have registered patterns. They have seat numbers. They sit there. Now, if you have a very powerful microscope and if you go into metal alloy, and if you can really look into the atoms, they are sitting in regular positions. Now you start heating this alloy. What happens? You're pumping energy into it. As a result, the bonds between atoms, they get excited, and once you cross the melting point, all the bonds break loose, and the atoms are flying all over the place. That is the typical structure of a liquid. When you cool it back, the converse happens. All the atoms slowly find their way and go into different positions. However, if you cool these alloys extremely fast, that you don't give enough time for the atoms to go and sit in their seats, what happens is these atoms freeze, and they have a random structure. This random structure is extremely attractive for many wear and corrosion properties. The trick is, you design an alloy that when plasma strain, under the conditions of cooling rates that you see in plasma strain, is able to get this amorphous structure. So any alloy, if you cool it sufficiently, can do this sufficiently fast. probably need about 1 million or 10 million degrees per second cooling rate. But what we have done is we have tailored the chemistry so that this alloy, when undergoes the cooling rate that you see in plasma spraying, does give you an amorphous structure. Now, how did we go about this? A couple of years back, we were looking at the amorphous technology. We evaluated a few competitive materials. We found some very attractive properties. I think one of the couple of materials that we looked at were the allied materials, which were actually crushed from metal spun ribbons. It had some very good properties, some very good wear properties, corrosion properties. However, they had two major disadvantages. These were, number one, the manufacturing technology was a completely different one, and it wasn't really scaled up. As a result, the costs were extremely high. You're talking more than $25, $30 a pound. Secondly, and even more importantly, these alloys had a very hazardous morphology. They are being crushed from a ribbon, a thin ribbon, and if you look at these powder particles, they are like a razor blade. Now, obviously, you're selling hundreds of thousands of pounds of these powders to customers. You don't want to have the liability. You don't want to sell them a hazardous powder. So with these two problems, what we did was we said, okay, we need a better morphology, we need a lower cost material, and also preferably a better composition which is proprietary. Now, with these objectives, what we did was we looked at one very important thing. We said, listen, you take these amorphous alloys and you plasma spray, you're going to obviously melt it first and then rapidly cool it in the substrate. If that be the case, there's no need to start an amorphous powder. What is important is the chemistry. So what we did is we need not go to the melt spun ribbon technique. We don't have to go to that route. We will go to simple atomizing route. And we found that we can get amorphous coating, provided the chemistry is right. So we then went on to tailor the composition. We added a few exotic elements and did a lot of work and found that with an appropriate chemistry and atomized powder, you can get an amorphous coating, which is a fantastic way of corrosion tolerance. And because we atomize it, we can make it easily, we can make it low cost. It's spherical, so it doesn't have any hazardous morphology. We also have a proprietary composition. And that's how Metco 700 came into being. After that, we did a lot of tests to see what this had to offer. We did a lot of wear tests, we did a lot of corrosion tests, and we found that indeed this has some very attractive properties. We are filing for a patent, which I think will be approved. Let's go into some of the tests. Next slide, please. Okay, before going into the test results, as I said, this is a nickel-based alloy. It's got chromium, moly, tungsten, etc. It is an atomized powder. Okay. We have made this in our centrifuge facility. We have gas atomized this. However, if we start selling this, hopefully we will sell several thousands of pounds, and if we don't have the production capacity in Penrose, we can get it done elsewhere by other atomizing techniques, for instance, water atomizing techniques. We have done that from outside sources. We have evaluated it, and the coatings look extremely good. Therefore, we don't have a production problem. Plasma spraying of this is fairly simple. The parameters published. Simple argon hydrogen parameters or nitrogen parameters. The coatings that you get from these powders are dense. The hardness typically ranges in the 40 to 45 in the Rockwell C scale. They have good bond strength. If you spray about 15 mil thick, you're talking in excess of 7,000 psi. Very interestingly, with this kind of hardness, you can easily grind it with aluminum oxide, silicon carbide. Of course, you can grind the diamond also. Right now, what we have done is we are offering this powder in two sizes. One is a 200 mesh down, another one is a minus 325. These two powders are plasma spray applications. We are also working on a much coarser size powder, same chemistry, for plasma transfer application. We've done some very preliminary tests in PTA, and the results so far look good. However, right now we have two plasma spray powders, 700 and 700 as I said. Next slide. Okay, I said we have done a lot of tests, and the first one is wear test. Okay, we did abrasion test. We used the study method, the in-house test method, compared this abrasive wear to several baseline coatings. The obvious one is a 15E plus self-fluxing alloy, the standard comparison. And we find that it's about 85% of the abrasive wear resistance of a few self-fluxing alloy. Okay, how about other candidates? We also looked at Metco 130, we looked at 501, we looked at these two. We looked at these two as other baseline, and we find that this is as good, if not slightly better than 130 and 505. So I think you get the picture. The Metco 501 and 130, about 75% of an abrasive wear of fused 15E. And this is between Metco 130 and fused self-fluxing alloy. That gives you an approximate idea of what the abrasive wear resistance is. The reason we have done abrasive wear test is because we think we can use it in several petrochemical applications, maybe piston kind of pumps and slurry components where you have some abrasive slurry, erosion, abrasive wear, that kind of application. I think there is a potential there if you need a coating that cannot be fused, if the substrate cannot tolerate fusing. If you need a plasma spray alternative to a self-fluxing alloy, I think there's certain potential there. Yes.
Did both materials have 85% 15F, or is only 700F?
Both. The second thing is we wanted to look at scuff resistance. It's pretty obvious why we look at scuff resistance. There's a tremendous market in the piston ring area, tremendous market in cylinder liners, things of that sort, where you need scuff resistance. We looked at scuff resistance against two main surfaces, case hardened steel and cast iron. I think cast iron is probably more important as far as the application is concerned in the cylinder liners, piston rings, etc. The scuff resistance is very good against case hardened steel, but more importantly against cast iron is simply fantastic. It outperformed Moly wire coating. It is better than tribaloid. It was better than any other coating that we looked at, 501, 505. And interestingly, a couple of days back, when we were having the open house, we got some results from Professor Alan Levy, who does a lot of work in the Lawrence Berkeley lab to evaluate coatings for cylinder liners. We had sent to him about several months back Metco 700, 750, tribaloid, that is T800, 350, Moly, a whole bunch of coatings, about 17 samples to look at wear against steel, wear against cast iron, wear against self-mating surfaces, and in different modes, in oscillatory motion, in sliding motion, etc. And the results that we got, I'm very proud to say that Metco 700 simply outperformed every other coating, including 350, including Moly, including tribaloid, and everything else. And that is extremely encouraging for us. The reason I'm saying this is because I think we really want to promote this in some of these applications like liners and piston rings. Piston rings maybe not the automotive, but maybe the high temperature diesel piston rings. So we have sensors out for that kind of an application for field test. Ramsey is doing evaluations in piston rings. I believe, I think Francis is following that. We should get some results very soon on how this does. We've also applied a coating on a Wankel engine end plate, which is a cast aluminum silicon substrate. We applied it, and the last time, a couple of weeks back, I spoke to John Deere. They said that the engine test is being done, it has accumulated about 200 hours plus. 200 hours is a pretty good time for them, so it's still going on. So So I'm extremely encouraged by the scuff properties of this material, and I think that is one major area I would like to see this go. I think that's where it will work. Next slide, please. The second thing is we want to look at corrosion. Now, a lot of people in the marketing group, when you say corrosion, they sometimes tend to get carried away and they assume it's good for every kind of corrosion. Obviously, you know that there are at least 100 different types of corrosion: aqueous corrosion, high temperature corrosion, low temperature corrosion. And we have to be very careful when we promote any coating for corrosion application. The kind of corrosion tests that we did for this alloy are aqueous corrosion, corrosion against liquids, corrosion against acids, corrosion against alkali, corrosion against salt water, and not high temperature corrosion. If you want high temperature corrosion, excuse me, against sodium, sulfur, chlorine, vanadium, etc., you go for 461 or something else, or emsolid. This is not for that. This is for low temperature aqueous corrosion.
You're saying it is not for high temperature corrosion?
This is not for the high temperature corrosion in gas turbines, like sodium, sulfur, chlorine, vanadium, etc., or even in the DNRB type corrosion. Okay. This is for aqueous corrosion. Maybe it might work in some cases, but at this time I'm not promoting that.
What would you say is the max temperature?
Well, we have taken this coating in an oxidizing atmosphere up to, we talked about that, up to 1800 Fahrenheit, and the oxidation is less than 0.2%. We'll come to that. Okay, so now we are interested in aqueous corrosion. We tested it in several acids, concentrated acids, alkali, and uniformly this was excellent against all kinds of aqueous corrosion. Now we went to a hot sulfuric acid corrosion test, which we thought was a very severe test. And we compared with several baselines. As you can see here, the ROT 1020 steel just gets eaten up in no time. It was 80 inches per year corrosion rate. And the best baseline that we had was the alloy, which is known in the industry to have the best corrosion against sulfuric acid. And that had about 40 mils per year corrosion rate. And Metco 700 was about 20 mils per year. So it's sort of in the category of alloy, if not, it's about twice as good in the hot sulfuric acid corrosion. Now this is important again because this is a very aggressive accelerated test, and I don't expect that in most applications you have this kind of a corrosion rate. In a typical sulfuric acid condensation reaction, you probably get about 1/10 or 1/100 of this kind of corrosion rate, and you probably can get several years from this coating. Because we saw this good corrosion resistance, we applied a test patch in Exxon about a year back. I believe until that time, other coatings that had been tried in this regenerated stack had not worked, and they desperately wanted a coating. And the problem here was you have a lot of sulfur dioxide fumes going up to the smokestack, and they condense and form sulfuric acid. Okay. We were only about 50 to 60% confident that this will work because you have a little bit of porosity in the coatings anyway. And we applied it without a sealer. And till date, I have had no complaints. We have not gone inside the boiler and seen how the coating is, but apparently it's working and they're working with it. So what I'm saying is that this has the best chance in that kind of an application where your acid corrosion is a problem. I think we certainly would not, in all cases, recommend going only with the coating, but we would additionally put a sealer as insurance. But I think we've got a good chance in the smokestacks and the scrubbers and the digesters where acid corrosion is a problem, and that's a huge market. Okay. Next slide, please. Okay. Another area of interest for us was in the aircraft industry, where I know they have been using Tribal T800 for high temperature wear, and Bob Zulik was pounding in our office saying that that's a big market, we should get into that. Now obviously I want to look at it and compare the Tribal 800 as an alternate for the aircraft market. I wanted to know the high temperature properties. I mean, is it oxidation resistant or does it fall apart like a Hastelloy? You know, Hastelloy has got fantastic corrosion resistance at room temperature and acid, but you heat it to a high temperature beyond about 1500, it falls apart into a powder. We tested at 1800 Fahrenheit for about 15 hours, and overnight we tested it, and the weight gain we found is less than 0.2%. It is comparable to T800 in that regard. And however, if you do expose it to that kind of temperature for a long time, the alloy will undergo some amount of recrystallization. That is, it will lose its amorphous nature. It's okay. I think the interesting thing is that if you do recrystallize it, if you lose amorphosity, you lose some properties, but the coating doesn't fall apart. Your wear rate might slightly decrease, your corrosion rate might slightly decrease, but it still is there, protecting the substrate. The important thing is that why should anyone use this against preferred over tribaloy? You know, tribaloy is a good coating, it works. The reason is tribaloy has got the best properties only after the heat treatment. The tribaloy, if you add plasma spray coating, it's a very porous coating, it doesn't have integrity, it's got poor wear conditions. However, the best properties of tribaloy are obtained if you heat treat it at, say, about 2000 Fahrenheit for a few minutes. Now, you obviously can't afford to heat treat every substrate and every coating, and secondly, it's also expensive. This coating, just plasma spray, without heat treatment, gives you that kind of property. And that's why I think the aircraft people will be interested in this.
You're saying that it will give the same properties as Tribaloy 800 after post-heating Tribaloy 800.
Tribaloy, you can plasma spray it, it will have lovely properties. You heat treat it, it becomes very good. Metco 700, you plasma spray it, it is as good, without any heat treatment, as good as the heat treated tribaloy, if not slightly better.
How have we proven it?
We have done a lot of tests. We have done hot hardness tests. I will show you a little later. We have done hot hardness tests, which is an indication of its strength at high temperatures. We have done hot hardness up to 1400 Fahrenheit. We compared cellulite coating, tribaloy aspirate, tribaloy heat treated, and Metco 700. Number two, we have done a head-on comparison with T800 for all kinds of tests, abrasive wear, scuff wear, both in the heat treated condition and plastic. We have a whole report if you're interested in that detail. Okay, so we have made all comparisons. Yes. Well, it is being evaluated in LIN, lens.
Do they have that report?
Yes. Next slide. Yes.
How did it compare directly with the Tribaloy 800 going through the same heat treatment process?
Okay. I did that. I heat treated it. I mean, I wanted to see if you heat treat it like tribaloy, that it gets screwed up. I wanted to see that. I give the same heat treatment. And as far as the wear properties, there is no law because cool back has got the hardness and everything. Its hot hardness is the same. The only thing is that its scuff against hardened steel goes up slightly. Okay, it loses a little bit of corrosion, but for the purpose for which Tribaloy 800 is used, it does not get affected. In fact, scuff against cast iron is much better after the heat treatment. So it gets densified somewhat. Okay. I will give you the copy of the reports that we have put together on this, specifically for comparison with Tribaloy 800. Okay, this is the hot hardness I was talking about. As you can see, the blue lines, you got two blue lines. One is continuous line and one is discontinuous. The lower one is the hot hardness of Tribaloy as plasma spray. And the upper one is the one that is heat treated. As you can see, the red line is Metco 700. The hot hardness as a function of temperature is about the same as a Tribaloy 800 heat treated. and that's significantly better than a stellite coating. Okay. I think I'm pretty much done with the slides. I just want to add a few more points. We have looked at, another big major market is, as we all know, is the valve business. And we want to look at the PTA version of it. We took the course of alloy, like an 80 over 325 cut, and we did actually PTA. There's both on valves and also on coupons. We did some studies on the wear rate, the microstructure, etc. What we find is that the microstructure is typical. It looks exactly like a stellite 31 coating, which is used in the valve business. The hardness is a shade low, sort of less than a stellite 31. However, the wear rate is more than 50% better. Okay. Now this data is preliminary. We've not done all analysis, but so far it looks good. If someone is interested in looking at a PTA coating, I have a piece of it here. It's about an eighth of an inch thick. That's what we applied. We could apply thicker. We have a very dense coating here. However, we talked about a lot of good things about this, and I want to say some limitations of this coating also, so that we don't go into wrong applications. Number one, I don't recommend this for high temperature sulfidation type applications. Extreme, like the VLRB type coating. Heavy sulfurs around and high temperatures, you're talking about 1,000 Fahrenheit and above. It also, yeah.
No high temperature sulfidization, is that what you said?
Yeah, it is not recommended in applications where the M-Collie type materials are used. Where they're talking about high temperatures, sulfidation. I think you're better off going with the coating like Metco 461.
What do you consider high temperature?
I would say high temperature is 1300 and above. That's where the sulfidation reactions are most worse. I also don't think that we should, I also don't think that this will have a tremendously superior erosion resistance. We have these applications in garbage boilers where I'm told that we have a severe erosion problem. Okay. Because we have an abrasion resistance and stuff resistance and acid corrosion resistance, I don't think that necessarily translates to a superior or an order of magnitude better erosion resistance. Erosion resistance is only as good as over typical composite material. It's not any better, it's not any worse. It's in the same ballpark. So I don't think it will necessarily be superior to our current coating in a severe erosion condition, or even a cavitation erosion. Another thing is, this is not a self-bonding, one-step-like coating. It's got a thickness limitation. The coarser powder Metco 700, you can spray it about, safely on a flat substrate about 25 mils. The 700F you can go about 20 mils. So this is a thin coating, thin wear-resistant, corrosion-resistant coating. Okay, it's not like the Metco 450 where you can spray infinitely up to 100 mils, 200 mils. Yes.
Put a bond coat on.
Yes, if you put a bond coat, you can almost double the thickness limit. Okay. Number two, if you spray it in a part that's got a cylindrical geometry, you can spray a much thicker coating, obviously, because the coating is shrinking and holding on tight to the surface. Okay. So I think in those cases, you can apply a thicker coating, but in the worst case, it's a flat surface. You don't apply more than 25 mils without a bond coat. Okay. The third thing is we were interested in the tape-head application. Tape-head application is another good market, and the coating has got all the good characteristics, but one of the things is that it doesn't stick very well to copper-based alloy. Okay. Tape-head substrates are brass substrates. And I think one can make it work by some trick, keeping the substrate very cold and blasting it very well and giving it a very rapid traverse rate. But it's a little tricky. I think the people who wanted to use it in the taper have to take some pains in development. Maybe it will work. But it's got the wear properties. So that is another limitation. It's not the greatest bonding for copper based substrate. However, it does bond well to aluminum substrate. We have seen that in the vacuum engine application. Overall, I am very proud to be a part, for having developed this alloy, and I think this alloy is a good one. I really believe it. I'm not saying that I developed it. I think if we market it right, I think this can be a real big winner for us. I want to give the kind of assurance to new people who are going out there and going to sell it. And this is really a good coating. I really believe that. Okay. I think it's got the abrasion of a 130 coating, it's got the stuff of a moly coating, it's got the corrosion resistance of a Hastelloy sheet, it's got a PTA ability of a stellite coating. You've got the whole thing in one package. Okay. I think that's very good. It all depends on how smart we go and work on this application. Thank you very much.
Two materials. Okay. Good morning, everyone. I'll be talking about, again, two very new and very important materials for Metco. Number one is, the first one I'll be speaking about is Metco 750. Then after that I'll be speaking about the Metco 480 MS. Okay. As with Runga's product, Metco 700, many of you have had some exposure to this material. So you do know something about it, and other people may not, but that's why I'm here today. This material, Metco 750, is this patent applied for, along with the Metco 700. This is a new hard-facing, corrosion-resistant alloy. And what I want to stress about the 750 in this talk is the high point, of course, of the product, and secondly, how it might differ from the Metco 700, because there seems that there was some confusion lately about the differences between these materials. And finally, I want to also mention that this material is undergoing some development. It is not as far along in the developmental stage as in the stage that the Metco 700 product is. And the reason for that is that, again, both of these products are the 700 and the 750 are atomized, gas atomized at the time products. Lately we're going to a water atomization of this product, but that really doesn't affect it. The main thing here is that this product in its early conception was produced at a certain formula and we found that we ran into some manufacturing problems when we scaled up. And this did require changing the formula a little bit. It does not appear to impact the numbers that have been printed in the brochure very greatly. Those numbers will be revised when all the development work is completed with this newer material. Is everyone clear on that? There is typically some growing pains, particularly with alloy products. It's not like a composite powder. Well, even there you have lots of growing pains also.
How much do you think that lower discovery is?
We're measuring that now, however, it does seem to have lowered it slightly. Again, the material is a nickel chromium high moly type alloy. It does contain boron, silicon, and carbon. That permits the material to be self-luxing. That is the major difference between this product and the Metco 700, is that this product can be fused. The Metco 700 product cannot be fused by conventional methods. The 700 product can be applied by the PTA torch, and that's been looked at. Of course, that's a high temperature welding type process. We've also looked at this alloy by PTA, but I don't consider that a typical fusion. This could be fused by the typical methods of either a torch or induction coil or furnace fusing. Discovery resistance is lower than the reported values. We're defining them right now because we have some current lot of material that represents a large scale. The main thing, though, that with this product is that it is, go to the next slide, please. The high point of this product that makes it different than anything we marketed before is that it has this extraordinarily high coating density and very clean microstructure. The photograph here, the microstructure that's shown here and shown in the brochure is the acid sprayed plasma coating without fusing. Some people during our customer open house were getting this microstructure here confused with a fused coating because it does look that clean and that dense. There was a lot of questions also from customers as to what these secondary components are in the coating. You see that there, of course, there's these, it's a dispersion of crystals in the coating, and that provides this high wear resistance. These crystallites are crystals we've identified so far as they're complex. They're mostly carbides and silicides and borides of the chromium carbide type, moly type, and there is some tungsten in the alloy, but there are some tungsten carbides in here too. So it's like it's a mixture of those kinds of materials. That gives it its high abrasion resistance. But again, the microstructure, I think you could do a lot of selling for this product based on the microstructure that shows that it's an extremely dense and clean coating. If you have a plasma sprayed Metco 15F, you know that it's a very clean coating. And it does have a very clean microstructure also. That's how this original research work started out. We wanted to develop a coating or a manufacturing method for materials that would produce very low or virtually no oxide coatings with high density. As you know, or as you might realize, generally where materials, when they're thermal sprayed and they show very high oxides, they also show correspondingly rather high porosity. So if you could reduce the oxides of the material, you could then just improve the coating density. And of course this is shown in, by vacuum plasma spraying, where the oxides are not there, and the coatings are very dense. And you can do this with open air spraying. You don't need shrouds, and you don't need a chamber. Okay, what is the value then, though, to that kind of structure to a customer, obviously? The value is that the coating does appear to be 100% dense. The measurements do show that. However, I don't think that we're ever in a position to market materials that way, because even our fused coatings, when they're of course, those are fully dense materials. We do see porosity, through porosity occasionally, depending upon the geometry of the part and so on, even with fused coating. So we can't really guarantee, we can't make a guarantee to a customer that the material will be fully dense and behave like a fused coating every time, because even the fused coatings, again, are not always non-porous. However, it does come the closest to anything we've ever offered in terms of high density. I have sprayed this material in 15 mil thickness onto steel pins and immersed these with pins into acid and found no through penetration with a 15 mil coating without a sealer. I believe that the Metco 750 will enable us to get into a new market of chemical process equipment where there's a combination required of very high corrosion resistance, very high coating density, and high abrasion resistance. I think that's going to be the market that this product will be most successful in.
Again, it's a homogeneous, atomized product. It is not a composite material. You probably could never get this kind of coating structure with a composite material. The wood does require the alloy. We found that the reason for such a clean-looking coating is the fact that it does contain boron, carbon, and silicon. If you remove those elements from this alloy, the material then resembles a typical nichrome. So then you're left with nickel, chrome, and moly. And it does contain a little bit, as I say, tungsten and copper actually in there. But if you take out those the boron, carbon, and silicon, you find that when you thermal spray a product like that, which then is like something like our 43 or 44, and you find that there's a typical oxide content in those products. But if you could incorporate boron, carbon, and silicon, you find that you control it. That's why 15F rather, when plasma sprayed is so clean. However, 15F does not have the properties that the 750 does. This is far better in coating performance than a 15F. You cannot get this kind of coating density with 15F. You can't get this kind of, even the kind of coating thickness you can get with 15F. It's been my experience. But it does generally resemble that. As you know, that some of the shops are doing a hell of a lot of work with 15F. They're doing just a lot of creative things to make a lot of money with it. I know there's a couple of shops that really believe it. That's without fusing. Some of the other high points of the material, again, are the very high chemical corrosion resistance. Being that this is a fusible material, it is not recommended for high temperature applications. It has even more temperature restrictions probably than something like the 700. And the reason obviously for that is that it does have a definite fusion temperature. But we are, again, I think it's going to show its best home in a chemical process environment. And the chart, and let's go to the next slide. Thank you. That shows the comparison. This comparison is the same one used that in the 700 demonstration or talk before by Rangaswamy. Again, we use a baseline of steel. Here I have a fused Metco 15E coating because we were targeting against that kind of product initially, a fused coating market. Finally, the 750 is there as a red bar. It does seem to perform about the same as the Hastelloy C spray coating. The 700 coating shows even better corrosion resistance in sulfuric acid. I had one customer at the open house ask me about the numbers here. She said they're very, very high numbers. And again, when you're showing this brochure, or even for the 700, it's important to point out that this is an accelerated test. And he said, my gosh, it's still showing, what is it? Can't see the numbers, but it's 40 inches a year or something, mils per year. I can't, how could I use a coating like that? But again, remember, this is almost boiling sulfuric acid, 25% sulfuric acid. Is a very strong concentration. As you increase the concentration of sulfuric acid, its activity becomes lower. This is sort of a point where it is extremely aggressive. We've exposed it for 3 hours. Now, also, you should point out to potential customers that these tests that we've showing in these brochures are for freestanding coatings, and they're not for coated parts. Okay, but they are without sealers. So it's important for you people to know what methods and we use to prepare these booklets and the way we tested these things. But we believe, I believe that the 750 would show, that it has shown in the laboratory, it shows sulfuric acid here, but would have a wide spectrum use against the chemical media. That is, it seems to show also excellent performance in hydrochloric acid, phosphoric acid, alkaline materials, and a lot of these organic acids. So it should be well suited to chemical process industry. I would encourage the material to be promoted at least an initial basis with, always with a sealer, but I would point out to the customer that we have a lot of built-in insurance with this kind of microstructure when it is new. I think the second high point, in addition to the corrosion resistance of the product and its good structure, is that it has this high abrasion resistance. The abrasion resistance of the plasma spray coating without fusing is equivalent now to the fused 15E, where the Metco 700 that was just talked about is about 85% the abrasion resistance of fused 15E. This is equal to. However, you've got to also be careful there in that it's important that the customers don't misunderstand that this material is still not a fused coating. It still has the characteristics, all the other characteristics of a plasma spray coating. It is a hard coating. It is plasma sprayed at Rockwell C50. And with that kind of hardness, obviously you can't expect that it's going to, as an unfused product, plasma spray, to have the kind of impact resistance that the fused coatings have. Obviously, they always have higher impact resistance. And why is that? Well, they're fully wetted and they're married to the steel components. And the coatings, when the coating is fused, then it has very few fault areas. There's no grains, there's no particle boundaries anymore to worry about, which is usually our biggest weakness in our coatings. The fact that raw materials are comprised of individual splattered particles that are held together. So that the abrasion resistance, again, is equal to the fused 15E, and we will, that should be a strong point, because that is a very good number. And the reason for the good abrasion resistance is this built-in hard phase dispersion that is shown in the microstructure. The next thing about Metco 750 is that it has shown this good friction and sliding wear. Not with the initial work, with the original composition, which was, again, a nickel chrome. The original composition was 17% molybdenum. And some of these people who have worked with that product already, we have to reduce the molybdenum. As I said, we are looking at what change that has on its coefficient of friction. But it doesn't appear that it's going to be a major change in the friction coefficient. Nonetheless, the original product did show properties superior to spray bond. And I think that even with this change, we're going to be in that general area. I believe that, and the reason I believe that is because I've also, in the early development work, have looked at reducing the molybdenum content real low in the product. And the molybdenum in the alloy does seem to control the scuff. And even at a very low concentration of welding in the alloy for some patent purposes, the scuff resistance is also quite good. The next point about the material, and I mentioned already, is that the product is fusible. And the fusing temperature of this product does seem to be a little bit higher than the conventional products, that's the 15E type or the 12C, etc. Those products generally have a fusion temperature of about 1950 Fahrenheit, 2000 Fahrenheit, somewhere about there. This product, because it does contain a considerable amount of molybdenum, does show a little higher fusion temperature. And that fusion temperature has been estimated by some furnace testing to be about 2200 degrees Fahrenheit. It doesn't have the typical, the same kind of shine that you develop when you fuse something like 15E. That effect is a little bit less apparent. So it does mean that there's going to be a little more technique. And as you know, all fusing of coatings is a sort of technique. You can underfuse a coating, you can overfuse a coating, and that goes with all our full product line. And some people, I know that Joe Antel has come back to me with some samples he has fused, and he said, well, I don't get quite the same hardness to you. And I go back and I get these kinds of hardnesses, and it does seem to be dependent, as many of these fused coatings are, as to the geometry of the part, the heat input, how it's done, and so on. So we do have that consideration when you're fusing. The fused coating hardness of the plasma spray coating appears with the newer material to be about Rockwell C60. Some earlier numbers were higher, and it does seem that we're coming in about the Rockwell C60. However, that's about the same as Fuse 15E. However, the abrasion resistance now, that's the next topic of the fuse coating, is greatly better than the Fuse 15E when it's finally fused. I should also mention at this time that the product Metco 750 is going to be offered in sort of three particle size distributions. The fine powder size distribution for plasma spray, which we'll be showing here. We're talking about mostly. The second kind of size distribution will be something like a 12C, which is a 1:20 mesh by 325 mesh. And that's geared for combustion spray, obviously, plus subsequent fusing. That is not to be designed for a non-fuse situation. And thirdly, we do plan, when we develop more information, to offer this for plasma transferred arc market, which is then another size cut, slightly broader yet. When we fuse either the plasma spray material or this combustion spray version, we find that obviously the wear properties are greatly enhanced. We find that the wear properties of the fused plasma spray coating is about twice as good as the Fuse 15E. And that is a strong point because that puts it in a position of about 70% of something like 34 ref. So you're starting to push in with abrasive wear in here of the tungsten carbide containing materials at a far lower price. I think the pricing of this material is about the same as the 700. And it is a good pricing. It's quite competitive with the carbide type material. I mentioned that we have looked at this product for PTA deposition, and with some limited work, the other coatings do look equivalent to the Metco 700. I don't have the sample here with me, but it does look the same as the 700 product. The 700 product does, when it's PTA, does seem to provide maybe a little more forgiving maybe. This is a harder product. It does contain more. It does contain carbides and borides and silicides, but the 700 really doesn't. So that maybe it's not as forgiving with PTA. However, at the same time, the abrasion resistance, the samples that were done were brought back here and we checked it. We found that it's about twice the abrasion resistance conservatively of the Stellite 6, pushing almost 3 times the abrasion resistance. Now this is a nickel-based material, so and the Stellite, of course, is a cobalt type. But nonetheless, it does appear to show real good properties as a PTA material. Again, going to some of the other things, I think that the major market for this will be the finer particle size distribution for the plasma spray coating. And with that, you should know that the plasma spray coating does, just like the 700, it does have, or anything else, has some shortcomings. And that's what I want to talk about now. Number one, material, like the 700, it's not a self-bonding material. It's not a one-step coating. It's the same in that regard as the 700. It is designed for thin coating applications for plasma, with its plasma spray. And that being about 20,000 on a flat surface, that's the sea-grid plastic with no bond coat. And again, a flat surface is a very difficult surface, but it is about 20 mils. The bond coat is used, what appears that we can double or about triple that thickness limit. However, the bond strength is high, measured by the tensile bond strength measurement, where the coatings are thin. So the 10,000 coating or 10 mil coating on grid elastic steel, bond strength does showed to be about 8,000 psi. As you know, generally speaking, the harder the material, particularly plasma spray materials, as the coatings become harder, their thickness limit becomes lower. And that's true all around. You can't avoid that. And there are some bunch of technical reasons why that is true. I think one probably the major technical reason is, of course, it's all due to stresses and shrinkage of the material. Shrinkage on a micro level. So that this material does behave that way too. That's why the thickness limit is about 20,000, maybe 25,000. As the material cools, it does shrink, it does form stresses, and that provides the upper limit. Just like our carbide products, our line of carbide cobalt products, they all have this lower thickness limits. If you look at bronzes or aluminum and things like that, they're low stress materials, 447, so on, they're all low stress products. They have very high thickness limits. So it's always important to remember that the coating shows a very high hardness, and this does, it's a Rockwell C50 as plasma spray, which is a very high number for a non-carbide type material, incidentally. If you look at our product line, if you look at the coating hardnesses obtainable as an as plasma spray coating, excluding all the carbides, Rockwell C50 is a good number. And as I say, it does show an equal wear resistance to Fuse 15E. Yet Fuse 15E is Rockwell C60, remember. And yet we're showing with C50 the same kind of abrasion resistance. Why is that? Well, principally because of this, the chemical makeup of the alloy, the fact that when it's plasma sprayed, it shows these low oxide identities. So, just to recap the whole the topic of Metco 750, it offers as a plasma spray coating, the high density, the low oxide, the good corrosion resistance, and the good abrasion resistance. It has also shown some good benefits from low friction, and it can be applied by plasma transferred arc. As far as the ongoing applications for the material, there's been some good success at Akron Sandblast for coating anode heads in a galvanizing line. That Alcave is successful with to some extent. Unfortunately, they're changing the design. His customer has changed the design somewhat of this anode head, and he may not be spraying those components anymore, but those parts were required reasonably good electrical conductivity, very high coating density, and good abrasion resistance. So we went in with this product 750, and it was looking very well. They were seeing sulfuric acid exposure. I think the other application that it's running in right now is it was successfully put down in a very large roller for a galvanizing sheet strip line, where the roller was coated with and somehow they put down 40,000 of this product on a very large diameter roller, and they successfully ground that roll, and was used to convey sheet strips into I think a sulfuric acid type cleaner for stripper for whatever, for these galvanizing line. And another application that's by Westinghouse, and there is a lot of interest there by Westinghouse with their customer, which I believe is a Swiss company, at least a European company, and they have placed an order for more material. I will now open it up to any questions on the 750 before we get going on the 480 NS. Right.
You go to the moly content and the heat material.
Yes, sir.
Would we be afraid to run that on a screw on a hardened barrel?
What is your usual baseline product that works well or that you would consider moly wire? I would still go in with 750. For that purpose. But what I've seen is As I say, we're redefining the nutrition right now. We should have those numbers within a couple of weeks. From what I've seen of the very low moly alloy that we have looked at in the past, that was still good. So I would think that this is going to be right in between.
How much knowledge you pulled out of that?
We pulled out, we're down to 12 approximately. We were at 17. We have looked at 10 moly. That looks okay. That looks quite good.
They had rather sacrifice the screws in the barrel. It's a hardened barrel.
Well,
we don't want the screws to wear out the barrel.
Right, I can very much appreciate that. We will be providing the friction aware numbers against hard steel, cast iron, and we should have those numbers available in a couple of weeks. And then I can give you a better answer on how we compare with the older product at that time. How about some other questions? Okay, and that, this is an extremely important product for Metco, obviously. It's been a long time coming. I think everyone will agree. 480NS, as you probably know, is a pre-alloyed, or what I like to call fully alloyed, because there's a little different approach, atomized nickel aluminum product. It took us a long time to provide this kind of product, maybe, but this product is damn good. It appears to be far better than the other nickel aluminum products that are out there on the marketplace right now. So you can go out there with this product and feel extremely comfortable, because you've got something here that's of far better quality and is far more forgiving and has far better numbers than the competition. Move the slide forward, please. I think the one major strong selling point of this product will be the fact that it has the ability to be sprayed in a very forgiving manner. The bond strengths are exceedingly high. When we first looked at this product, we saw these high numbers. So we repeated it again. We repeated it again with that same test mode, and we switched over to another way to measure adhesion. And we did that 3 times, and all 6 values were consistently high numbers. I know it's really an eye-opener to say that the average bond strength for this product is about 11,000 psi. But it is. It has been measured over and over with more than one lot of product. 11,800. Excuse me?
How sprayed? Sprayed with what?
Argon hydrogen plasma spray, I believe it's 9 pounds an hour, and it's something like a set number 7 of the 450 type. It does, all of these bond strength measurements, as I say, have been measured by argon hydrogen plasma spray, 9M system, 9 pounds an hour. Okay, so that's where the numbers were derived from. And incidentally, the high bond strength has been measured both on ground and grit-less cold roll steel. 480NS also shows very strong adhesion to many other alloys. That being, we've looked at it on stainless steel, Type 302, 6-4 titanium, 2024 aluminum, and pre-turning brass. I have a sample of the way it looks on brass over here. You can take a look at this later. We sprayed down about 50 thousandths of it, and I thought this was a polished brass, incidentally, and it didn't come up. So we tried to pry it off with a razor blade at the interface. That didn't work, and finally a chisel. And by the amount of material that's left on the surface, you can appreciate the kind of bonding that there is, and that's brass. I would be comfortable going into an area to repair or to use as a bond coat now for brass materials and possibly aluminum. That's preliminary data. The numbers are high. I've measured it. I have numbers on, for example, brass at 8,400. And aluminum is high too. We got to try it off aluminum. So it does It does show very exceptionally high bonding. Again, it is a pre-alloy product. It is not a composite. We will continue to offer, as far as I understand, the Metco 450 product. The 450 product may show some advantages later on, or again, a combustion spray, maybe, but here, a combustion spray, the 480 also, the bonding numbers are very high. However, I think that is far superior. Metco 450, incidentally, when argon hydrogen plasma sprayed, shows a bond strength of about 6,000 psi. Here we are about almost double that. You can, we've looked at varying the plasma spray distance from 3 inches, which is very short, way out to 9 inches. Recommended spray distance is 6 inches for the product. And the then test sample shown in the brochure. This is on shiny wire brushed 1x3 coupons, bench 5mm coating here, do show no spalling. And competitive products, when put through the same test, have shown spalling, particularly on the 9-inch spray distance. So it has a wide latitude. I did have one customer approach me and say, well, gee, I spray all my components on automated equipment, so what does it mean to me that you can vary the spray distance in such a wild way? Well, what it does mean, well, truly he is correct. We always must follow spray parameters to get the best results. But it does show the kind of flexibility. If you got this kind of flexibility in spray distance, you'll have that kind of flexibility most likely with some of the other parameter changes to some extent, I believe. Again, these numbers are the same for both ground and grit-blasted steel. Move to the next slide, please. We're very proud to say that we have been approved by Pratt & Whitney aircraft for the 480NS in General Electric specifications. So as another strong point, coating microstructure is shown here. This is the argon hydrogen plasma spray sample that is representative of those bonds. Samples that shown on the other slide, and that good bond that you saw. The microstructure is characterized, and obviously, like any pre-alloy products, or particularly ours, that has no free or unalloyed aluminum. That's, of course, extremely important, and that's what the marketplace wants for the gas turbine industry. Secondly, the unmelted particle content of the material at these spray parameters is exceedingly low. I think it's something about 3 to 4%. Which does make it approved to the Pratt & Whitney standards particularly. And porosity has been, Lyle small, estimated to be 0. But we'll talk about 0.5%. I mentioned that the product can be sprayed with both combustion equipment. We're developing parameters for the currently for the 6P. We have sprayed with the 5P, 5P2, exceedingly high bond strength numbers again. We will be developing spray parameters for similar to for degradable steel type situations that some people do. Again, use 450 for degradable steels. I don't know who we are, but I know that people buy it that way and use it. So we'll be we'll be looking at it that way also. It may show some advantages over 450 as an degradable steel, high temperature type, because it has no free aluminum. And I would expect that this coating has far better integrity than 450 because of that reason too. But we have sprayed it through all of the plasma hardware, and the coating was exceedingly good. It has no thickness limit, typical of a self-bonding material. But it can be sprayed with all of the 9M, 7M, the 11M, that's there, the NBN systems, and looking good. Argon helium. The spray parameters for this product will be provided for all of the nozzles, combinations, configurations. and it's virtually the lowest boiling. The composition, again, is typical of the 450. It's 4.5% aluminum, the balance of nickel. The particle size distribution, we're pretty much locked in there for all these specifications, which is 170 by 325 mesh. People will be asking you why these bond strength numbers are so high. Obviously, you're going to come out and say, well, I got 11,000 PSI, and they're going to look at, they're going to be skeptical. My answer, they're also going to ask you if the material is exothermic. Now, we're not using the word exothermic at this point, as we do with the 450. And there's a reason for that is that we're currently studying why this product does show these high bond strengths. We don't know yet. We are going to find out why. So until that time, we're not using the word exothermic. However, it indeed may be exothermic as a pre-alloy product when it's sprayed. I would say that the reason for the high bond strength numbers is that Metco has a unique manufacturing process, a unique atomization process to prepare this product. There's a hell of a lot of ways to atomize materials, and there's all kinds of tricks to do it. It appears as though we have identified something special about the atomization of this material that gives it these high numbers, combined with the close control of the chemistry, the close control of the size. And I would stress that to potential customers, that we have a unique in-house controlled atomization process we believe is unique. And I would stress them our typical tight control, particularly on a product like this, an MS product, over the chemistry and the particle size distribution. But we're not talking about it as an exothermic product today. So until we can identify whether that's it does give that kind of reaction in the brain, we will not use those words.
Looks like a lot of our aircraft are missing.
They're not technical anyway.
Okay, all right. Well, what happens is after that presentation yesterday, I had somebody tell me, oh, the only way I can sell an APG is if I have an ATCS. No, we can sell APGs with interfacing with every 3M and 7M system, okay? So that little box on the side interfaces it, all right? Let me get that one clarified. But I want to go over this on the 4MP. We've got a number of complaints about the performance and reliability of the 4MP. And I can tell you, every complaint that you gave us, you were 100% right. We have a problem. Now, what we've done is we've addressed each one of these problems, and we're trying to come up with a package to correct the problem by doing this rework right in the field rather than taking it back from the customer. Now, Mark worked real hard on developing a retrofit kit. He's going to go into detail on this retrofit kit. We feel that this kit will enable you guys to go in, see your customer, and make the change with a minimal amount of problems. So he's going to go through it in detail, and he'll come up with a detailed set of instructions on how to do it. Is that correct, Mike? Okay, I'm going to turn it over to Mark. I just want to introduce it.
Okay, this is a little unexpected.
Put her on your line.
Okay, I put together a model of what I consider to be all the devices that have to be added on to the 4MP to make it work to current standards. The first problem we address is the problem associated with quick start and quick stop. And we single out two areas. First of all, with quick starts, we had very restricted filters. We were only fluidizing from the bottom. So what I've done is I've incorporated dual fluidization. So we're using two filters simultaneously all the time, and you're able to start the feeder up about half the time it normally takes. Another complaint is the time it takes for the feeder to stop feeding. It seems that in some applications, especially when you use extension guns, the feeder does not stop quick enough, and powder normally would enter into the hose, fill the hose up, and when you switched it on, you get a big slug of powder coming out. So what we've done is we've added another solenoid valve to the side. Again, all the additions, we made a key point to make it retrofittable and easy to change in the field. So what you're seeing here is not what we consider the best design from scratch, but it's the best design to make the switch over as easy as possible. We've mounted a solenoid valve out here, and this valve, instead of closing and opening a mechanical seal, it squeezes a rubber tube. Now by adding a few more machine parts at the top, all these unscrew. So you can, without any, let me just bring out one point. In present condition, there is no drilling, no tapping, no machine tools required to make the change. You literally need 2 adjustable wrenches and 1 screwdriver. So by putting this device up at the top here and running this line down to the side, you're able to switch the feeder on and off. So just to summarize, I've covered quick start, quick stop. We feel we have 2 modifications here that will make the feeder more acceptable in the field. Another complaint was can't leak check the unit.
Question.
Sure.
How quick start? What's that hopper on there?
Depends on the powder, the volume of the powder in the hopper. I'm looking at 10 to 15 seconds max versus 20 seconds. Another problem.
Versus what?
Versus 20.
30.
40.
Last of this.
Do I hear 50?
Last of this, I hear 50. Half is good,
Okay. Second problem there is the inability to leak check the machine. There was no facilities provided in the first design to leak check the device. So we've added a new gauge. Now again, this literally, you drop the front panel, disconnect some of the fittings, and you drop the new assembly in. And this gauge, in addition with the regulator attached to the rear end of this, allows you to leak check. Now there's 2 ways of leak checking. Everybody's familiar with the 3MP method of putting your finger over the powder port. Those of you who have sprayed before, put your finger over the powder port, you watch the ball drop. You can do that, but we found that that method of leak checking is okay if you want to look for a large or gross leak. To really get a good thorough test, you have to use a timed leak down rate. When you charge the canister and all the plumbing, switch off the feeder and actually watch the gauge. Now we've plumbed this in a way that you can actually watch the gauge. If it holds steady, there's no leaks. If it starts to drop, through a series of instructions, the operator can determine approximately where the leak's coming from. So now we've improved upon what they call the fantastic bottle technique of squirting water over the seals and looking for bubbles. You're able to pinpoint approximately where the leak is without using that method.
Now what do we do? Do we get a new gauge, or is
You'll get a new gauge assembly, and there will be instructions provided to plumb this in. You have to leak check it without powder, correct. I'd like to add to that, this addition, is we plumbed it in a way that we're able to diagnose gross speed problems. A complaint earlier is that gauge is an idiot gauge. It doesn't really show anything. You can run out of powder and it will still read the same setting. So we plumbed it in a way where it will tell you gross problems to the feeder, such as running out of powder, somebody running over the hose and kinking it. It will tell you of large variations, but it will not detect. The 3MP was able to detect powder port buildup and slight changes. This will not detect that. Okay, another biggie. All right, this is not a production version. This is a glued together prototype. I would say 90% of the problems are associated with glomerates in the powder or rigid particulates that lodge themselves in the powder hole. And we found that by putting a screen just above, it breaks up all the agglomerates and captures all the large particles. Now the screen, just drop it right in, it fits in the hopper, and all the powder must go through the screen. It works quite well. This will solve a lot of problems.
But that has to be cleaned periodically.
If you see, most of the problem particles are just small particles stuck together. And I've seen the vibration breaks it up. So unless it's a rigid particulate, like a piece of plastic from the bottom, you'll have to clean that out. You will have to take it out.
Powder is supposed to go through.
Right, right.
Mark, will that be fixed?
No, it'll be removable. That's true. That's true. Okay, that covers the main points, but a few minor details which I won't talk about. That's the way it stands. It's going to be a kit. We haven't determined all the additions that we're going to put in. We haven't really determined who is going to do it, whether field engineer, sales engineer, or the feeder setback. We haven't determined that yet. Tony?
Mark, our objective is to try to get it done in the field. Right now, with it sit on the top, I don't think it's a problem.
Right. If this does not look too ugly or unappealing, we can go with this and then we'll avoid something like this. This is the first approach, to drill and tap into the hopper, put a fitting in there.
I think our basic feeling on this, we'd like to have the retrofit done without drilling and tapping, because I think there's a problem. And as far as we're concerned from an aesthetic standpoint, I don't think it means anything. It's been used in commercial areas and no one's looking for something pretty. So I think our goal is to get this retrofit kit done by you. Now let's talk about this aspect of it, Mark, and see what their feelings are, whether they can do something like this in the field.
No problem. All right, I'll go through the actual retrofitting. It's to drop the back and front panel. This is the big one. This will be assembled here in Westbury. You install this with a lock nut washer and nut. You have to run 2 wires to terminal strips. There'll be crimp lugs on it, and you can unscrew 2 terminals, slide the lug nuts in, tighten down on it. That's all the electrical wiring that's needed. You remove the original assembly on the top lid. This unscrews, and you screw back on the new assembly. And you pop that on. You run a line. The line will already be in the valve. You run this line to the valve, and you're all set there. As far as the new gauge assembly, drop the front panel, and you will install a new gauge and run 2 lines to that. The dual pressurization requires a good amount of replumbing. You have to put inside, put 2 new bulkhead fittings in, which will provide. They're all pipe threads. Then you have to run a few new lines. That I consider probably the most complex part of it. You have to read flow diagrams, point A to point B, point A to point B. It's involved there.
We'll have this very simple, detailed sheet. Bob, we talked about this, I believe. You'll take care of making sure that those sheets can be interpreted by the salesman. Okay, detailed.
Gauge, but it's actually 2 parts of it. You have a gauge. Is that for solid rock?
The gauge is plumbed in a way that it will not be affected like the old.
The old one was, there's no way you had to blow the gauge. This one, there's no way you can. We redesigned the plumbing.
You have to change that silicone in there, let the gas in there too. Or we get too much gas or whatnot.
No, what's happening is the regulator, very complex assembly, and if something happens in there, it can overpressurize the gauge. We plumb the gauge outside that circuit, it's plumbed in with the carrier line. In addition to that, the regulator, which acts as a leak check device, also protects the gauge. So if the regulator in the unit is... Excuse me?
Three of them, all right?
Right.
Yeah, but this-
Quality control is looking into that.
This problem should disappear, okay? We've checked it here, it looks like, unless somebody does something that we haven't done here to simulate what's done out in the field, this should resolve it, right? Just to go another step further, so that everyone understands, this is a fit, a retrofit. We are working on a redesign, okay? I think the redesign is going to be dynamite. Unfortunately, with all the programs we've got, we shouldn't have the redesign complete till about 6 months. We're also looking in terms of a pressurized powder feeder for some other applications. So these are two major things. And Mark and Ed Gianelli are now working on a closed loop for you. And we expect to have something in 3 months for you on closed loop. So these are the three areas and powder feeders that you can be assured of in the next 6 months we should have ready to go.
I mean, the closed loop is going to be within the powder feeder itself?
No, closed loop tied in with Gianelli's 4MP800 concept. Two things, 4MP800, closed looping that now for us. The next thing is a new design hopper, okay? And the next thing is we're looking at a pressurization system because everyone's been asking us about it. We're hoping that the design, the change in the design of the hopper with some modifications that can also be used as a pressurized unit because we're making it a pressure vessel now, okay? But I just wanted to give you an idea that we're not stopping. Powder feeders and the guns are the crux of our business, and that's a continuous, ongoing program in engineering. All right? Any questions?
Mark, when you covered the exhaust thing, you went over it quite quickly. It might be helpful for everybody to hear what actually is that.
Okay.
And what it eliminates, actually what it eliminates happening.
All right. In order to stop the feeder from feeding powder, you have to open a valve inside the box and allow the pressure to escape out of the hopper. The early design had a filter, and that filter protected the circuitry, protected the release valve. But as time went on, that filter becomes clogged, especially with some of our key powders like 601. What we've done is we've added another valve that's immune to powder. Doesn't care what's going through there. And we have a direct line, no filter in there, direct line from that hopper to this valve. And the time it takes to depressurize the hopper is less than a second, as compared to 2 or 3 seconds. I'd say one more thing before we close. All these retrofits, this whole retrofit kit will solve what I feel is a big problem. It's still an area that we have to address. Elliot has pointed it out too. We have to educate the field on how the feeder works. It's very pressure sensitive. If they're not aware of if you change what will happen to the rate. We have to somehow educate the field. I was going to put together, in addition to this, a quick summary of what to look for, why the feed rate changes from change to carrier, to pressure, the oncoming pressure. That will be in addition to
Yes, so that's during the longer before we have to replace it.
Okay, the valve itself, we switched it on off like 500,000 cycles. We had a problem. We came with a silicone tubing, and that the powder or rotary was silicone tubing. We went to a latex, got rubber type tubing. I think we had like 200,000 cycles, and it shows that there. And it's very easy to change. You just take these 2 screws out, and the whole thing comes straight out.
I've seen
Talk about Metco 205. This is going to be a very brief presentation. I'm just going to overview this, which will get into a lot of the details of the material. Briefly, what we have done is, you all know about hot technology. We've been talking about it for several years now, and we've beaten death almost. Briefly, we moved into making ceramic powders by the hot technology, where we pre-alloy them. We get a spherical shape, and this translates into better life, better DE, better melting efficiency, etc., etc., etc. With this, we also simultaneously developed a new composition for thermodynamic applications. up till the development of this material, most of the thermal barriers had only two components. They had zirconia with a stabilizer. The stabilizer could be calcium oxide at 201, or it could be magnesium oxide like this 210, or it could be yttrium oxide, you know. But right now what we've done is we have put two stabilizers instead of one. Therefore we have totally three oxides in this chemistry. We have cerium oxide and yttrium oxide combined with zirconia, and this is giving us some very novel properties. That's what you're seeing right here. The chemistry is 25% cerium oxide, about 2.5% yttrium oxide, the balance being zirconia. Next slide. And the combination of these two, the hot technology and the new chemistry, is what became 205NS. Now, the objectives when we started this program were to develop a thermal barrier coating for the gas turbine industry and also possibly for the diesel industry. I think the gas turbine people will take a lot more time to get this into their tests and spec it in, etc., etc. I think if we go to the diesel market, I think we'll get the return for our money much quicker. However, I want to point out that we should not forget about the gas turbine. I think we should keep at it, but I think we should remember that the quicker return will be the diesel program. Next slide. This is how the powder looks. It's a fully pre-alloyed composition. It's got a spherical morphology, as you can see it here. If you plasma spray this coating, you get a porous thermal barrier, just like any other thermal barrier coating. It looks like a typical thermal barrier coating. Next slide, please. I think we should probably reduce the lighting a little bit. See the slides a little better. Doesn't help much. Okay, as you can see, we can spray this using a typical bond coat. We have used in most of our work, we have used Metco 461 as a bond coat. You could use an M-Crowley bond coat. You can apply it by vacuum plasma, air plasma, whichever you use. State-of-the-art 8 yttrium zirconia. Next slide, please. Because we felt that the 204, Metco 204 is an 8 yttrium zirconia is the state-of-the-art at this time. And we thought it's best to compare this coating to the best baseline. But there are three areas where we see major improvement. Number one, it appears to show more in our lab test and also in limited burner rate test that it does have much better thermal shock resistance compared to the 204 type powder. Okay, that's important for thermal barrier. It also has a lower thermal conductivity compared to the yttrium zirconia, and that's important because thermal barriers are supposed to be insulating materials. Heat insulation. It's got excellent hot corrosion against sodium, sulfur, vanadium, etc. I think there is also potential that this could be far better than the yttrium zirconia in terms of vanadium corrosion. Okay. Now, the vanadium corrosion is not so critical in the aircraft industry. I believe it's more prevalent in the diesel application, and I think this offers some good potential there. Other results like erosion resistance, they are about equal to the yttrium zirconia. So I think there are some 2 or 3 very major significant advantages compared to the yttrium zirconia, and some of the results that we got from Pratt are very encouraging. Caterpillar is quite interested in this. They are doing a lot of work. And right now I'll turn it over to Mitch to give you some more details of this. Thank you.
Here today is talk about the commercialization of Metco 205, which again is a series yttrium stabilized zirconia product. Now we reviewed Ranga's work, and we felt the best market for this material would be as a heat barrier in diesel applications. Specific components which we feel it might have the advantage is in valve faces, dams, piston crowns, and cylinder lines. Now, cylinder heads. Now, the cost of this product will be about 50 cents a pound less than 204, so it's a little cheaper. The reason for that is ceria is a lower cost raw material component than yttrium. Okay, one of the biggest problems that diesel manufacturers have is that they want to use dirty fuels or residual fuels that has high sulfur contaminants, sodium, and vanadium contaminants. Now, this becomes very corrosive and erosive in a diesel environment. Presently, yttria-stabilized zirconia products are being used or being evaluated, but they find that it does not have the hot corrosion resistance necessary for this type of application. We feel that a ceria-stabilized material will be better suited for this type of market. Now, one of the reasons for this is that vanadium attacks yttria, okay, causing destabilization of the ceramic, such as the yttria-stabilized zirconia. Other reasons is salt contaminants get trapped or condensed within the pores of a thermal barrier, causing cracking. So again, we feel that a diesel market are the best areas to investigate for this material. In addition, being that you're using, or you have lower temperatures, around 1500 degrees Fahrenheit in a diesel or lower, you can actually use 461 as a bond coat. Okay, aircraft applications see higher temperatures, and you would probably use an M-Prom. Next slide, please. Okay, so what we did is, as we said, we reviewed Ranga's findings, and we tried to find areas or market applications for a material such as a ceria stabilizer. And we felt that the diesel was the best area to initially approach it. Other areas that we looked at in the development aspects of this material was that we looked at the material and the spray parameters, and we redesigned these conditions based on customer requirements. We also evaluated the changes with 205, and we compared it to the baseline coating, and we scaled up the material in manufacturing, wrote up specifications, and we coordinated a field testing. Presently, there's work being done with Caterpillar, TRW, United Technologies Corporation, and Pratt & Whitney on this material. And also, we're looking at new coating systems, or three-layer systems, which incorporate a bond coat, a porous thermal barrier, and a thin erosion-resistant top coat for applications where you need more or greater erosion resistance. Next slide, please. Okay, first, one of the improvements that we did after we got the material from Ranga is that we changed the raw material size, the raw material constituent of the zirconia, to get greater chemical homogeneity in the product. That's one of the complaints that customers find, that going from one vendor to another, that there's problems with the chemical consistency of the product. So the way we approach that, we use finer raw materials, and then we spray dry this material in our manufacturing process. We also use higher chemical purity. One of the reasons that Dennis could attest is that aircraft manufacturers are looking at higher purity materials because they want, or they're concerned about the sintering temperatures of ceramics. And one of the areas that we're looking at is to reduce the amount of alumina and silica in these products. Also, what we did is we converted the spray-dried material over to a pre-stabilized hot material. The reason for that is we don't want stabilization to be dependent on the spray parameters or process. Okay? In the other areas, what we did is we made a narrower particle size distribution to get a more uniform coating microstructure. In addition, by cutting the size of the powder, we get greater stability in our powder. Next slide, please. This is cross-section of powder, okay? As I said, this was the initial powder that we looked at. You can see the large zirconia raw material constituent. What this means, from one particle to another, you have heterogeneous chemistry from one particle to the other. What we did, we took this material, we changed the raw material within it, and you can see it's a lot finer, and therefore the chemistry from one particle to the other will be more uniform. Now, uniform particle chemistry will translate to the material. What we did is then we took that material and we fused it to ensure greater chemical homogeneity, and also you get better flow characteristics. And you can see that it's a fused product and you have hollow spheres within the material. We feel that the hollow spheres will help in the deposit efficiency of the material. Next slide. Now, as I said, we also improve the chemical purity of the product. And you can see the differences in the alumina and silica levels. Again, we feel that reducing the alumina and silica levels in a product such as this will help the possibility of using this in aircraft applications if we can get into that area. Next one. Now, as I've said, we've cut the size of the material. Now, typically 202 is a 120 mesh material. Okay, it's a relatively coarse distribution. What we've done is we've cut the size of the powder so it's a minus 170 mesh material. Okay, the reason for that is we wanted to get greater chemical and structural homogeneity in the product. Now, what's important is the amount of tetragonal and cubic phase. The higher that phase, the better the product we feel. Okay? Now, our hot process is better suited for materials minus 170 as the particle size. And you can see that by the degree of stabilization of the product. See, there's a lot more tetragonal phase in our material with the minus 170 product than you do with the plus 170. Okay, there's also more unreacted ceria. Okay, next slide. This is just a graph showing that the effects of impurity levels, aluminum, what it could do to the melting point of the material. Okay? And in abradable steel applications, which typically go around 3,000 degrees, this can become critical. Okay, next slide. Okay, in addition to the redesigning the powder, we also redesigned the spray parameters. What we try to do is come up with a coating that is cost effective. There's a lot of different ways of designing spray parameters, but we look at the deposition rate and try to tie it into performance capabilities. Okay, next slide. Okay, here's a graph trying to chart deposit efficiency relative to power input. Again, we use argon hydrogen conditions here. And you can see the tendency is, as you go up in power, you get high deposition rate, and that's what you would expect. The problem with a thermal barrier is that you don't want a dense coating. And typically, as you go up on your power input, you're going to obtain a dense coating microstructure. The denser the coating, the poorer the thermal shock performance. So what we've done is we correlated the deposit efficiency relative to thermal shock. Next slide. I think it's the next slide. Okay. And this should really be 12 to 14% porosity. But what you see is that as you obtain a more porous coating, the thermal shock improves, and that's what you would have expected. So what we've tried to do is get the best thermal shock performance relative to deposition rate. Okay? Can you go back on one slide? Just one. Okay, what I want to say here is you can also see by using a -170 cut powder, you get more uniformity in your coating. There's finer porosity and there's a more uniform structure. And this is another attribute of going to a -170 cut powder. Okay, the other thing is I want to make you aware that different customers have different requirements, and again, they're looking for porous coatings. And I just want to show with these slides that the porosity in a coating dramatically affects the thermal barrier capabilities of a coating. Here are two different yttria stabilized materials. One is really a -270 cut, another is a 200 by 325 fraction. Now, these were sprayed with the same parameters, but they got different densities. What you find is the denser the coating microstructure, the less of a barrier it's going to be, thermal barrier. And you can see there's a significantly different effect as far as its conductivity. Now, based on Ranga's results, he's found that the conductivity of the ceria material to be around 1 to 0.9, so it would be down around here. Next slide. Now again, as I said, in certain applications, you're also going to need erosion resistance. So you have a paradox in a sense that you want a porous coating for thermal shock, but if you have a porous coating, your erosion resistance is going to go down. In certain applications, you need both. So what we felt is that you can design a coating system where you use a porous intermediate coating with a thin erosion-resistant top coat, possibly Metco 143. Next slide. Here's the bond coat for oxidation resistance, its thermal barrier, there's a heat barrier, and a thin erosion-resistant top coat. Next slide. So I just really want to conclude by that the yttria stabilized zirconium materials, as we have said, has excellent thermal shock resistance. Particle erosion resistance we found to be comparable to 204. We feel it has better Metco 449T. Okay, this is a new high carbon steel composite powder. Okay. This is similar in chemistry to Metco 449 with the finer particle size distribution. Okay, this material is designed to produce hard thermal spray coatings with finer ground finishes and denser microstructures in Metco 449. Now, cosmetically, plasma coatings are equivalent to wrought alloys, and I have a shaft on the side there we can take a look at later on, and you can see the capabilities of this material. In addition, we can use this material to salvage in OEM applications. But before I really begin this talk, I'd like to acknowledge the fine work and support of Frank Longo, Joe Reardon, Bill Rush, and Tony De La Rosa from engineering, and the support of people like Joe Antel, Francis Montgomery. Without their skills and expertise, I really wouldn't be talking on this today. Okay, now, next slide, please. The original objective of this material was to develop a material for crankshaft applications. It was felt that material like this would be more economically attractive than other techniques such as welding or plating. In addition, this process, or the thermal spray process, is relatively cold, so you don't have to worry about part distortion as you would with a welding technique. Okay, next slide. But for an application like this to be successful, we felt that it had to meet certain design criteria. For example, we felt it needed a hardness of about an RC 35 or 45. The reason for that is we didn't want parts to be scratched in service or in handling. One of the reasons. Surface finish we felt should be 5 to 10 micro inches. Okay, again, it's from a cosmetic standpoint, and also some technical reasons, which we talked about later on. We felt that the thickness capability should be about 50 thousandths on the radius because you need material to grind back. So we figure you put 25 thousandths as a final coating thickness. And the bonding, it has to be able to have a good enough bond strength where you don't have to worry about the coating coming off during the grinding operation. From what we've seen, there's a lot of operations where they plunge grind these crankshafts, and it's a very severe process. The other thing is that you want a high enough target efficiency where you don't waste material, and you also will have minimum bounce back from the counterweight. Next slide. In addition, some of the concerns in the application is that we really want to try to minimize the amount of dust entrapment. Again, we use PSIs. We try to look at the grinding operation on cranks, and we would kind of recommend using silicon carbide for applications such as this. Surface preparation is critical. In a lot of areas, they have nitrided materials, and it's very hard, and you probably would need like a silicon carbide or Meclite C type of glass. But surface finish is definitely critical for the bonding of this material. Other areas is you want to definitely put down less than about 2 mils per pass for a material like this, because again, it's a very hard material and it's very dense. Again, in the other areas, you got to be concerned about the thickness capabilities of a material like this. On flats, we generally get about 50, we recommend about 50 thousandths maximum. On shafts, you can put more, okay, typically about 75 or so, but it's dependent on the curvature of the shaft, size of the shaft. Metco 453 could be used as a bond coat. Okay, next slide. Now, we looked at a lot of possible materials that would meet the design criteria. We felt that Metco 449 was the most promising candidate. Okay, Metco 449 is a composite material. It has a cast iron core with aluminum and moly on the clad around the core. Aluminum is really used to enhance the bonding by exothermic reaction, which enhances the bonding of the material. Moly is used for scuff resistance. Boron is also added for hardening. Okay, but there were problems with Metco 449, and the problem is the surface finish that we get. Next slide. Okay, this is Metco 449, and what this is an SEM top view. And what we've done is we ground surface of the coating, and you can see the particles pulling out. Now these pores and the irregularities of the surface act as cutting sites with softer materials. And what we see here is the soft bearing type material, which can smear on to a 449 type material and get some scuffing. So what we're trying to do is improve the grind finish of a material such as this. And the way we did that is, next one, is by changing the particle size distribution and the spray parameters. Now what we've done with the particle size is we shifted the distribution of Metco 49 about 20% finer. Okay, next one. Okay, you can see there's more minus 325 particles within this product. Okay, next slide. Okay, and what this is here are two cross sections of the coating. 449, as you can see, there are large unmelted particles with more unreacted material. What that means is that the cohesive bonding of the material is a lot less than what you see with the 449T. In grinding, these large particles are going to pull out. Okay? 449T, you can see it's a lot denser coating microstructure, and we find that the interparticle cohesion is superior. Next slide. What we've also done is we've changed the spray parameters. Originally, 449 uses a G nozzle. A G nozzle is a relatively wide pattern. Here we went to a G heat nozzle. The reason for that is to get a narrower spray pattern with higher velocity. Therefore, you're going to have less material wastage. More material will go on the part. In addition, the fact that it has a higher velocity, you're going to get a denser structure. Finally, the third reason for using it is you can go further out on your spray distance. Okay? And in a lot of applications, you have to worry about the part geometry. Here, we generally spray around 6 inches, so you don't have to worry about the counterweights interfering with the spraying of this material. Next slide. Here we again see 2 coating cross sections. The first one being Metco 449 using a G nozzle. The second one being a GE. Now I don't know if you really can see the difference. There is, but it's not as dramatic as using the finer size particle size distribution. But the combination results in a very dense coating structure. Next slide. Okay, what we have also looked at is the relative abrasion resistance of the material. Okay, as you can see, Metco 449 is superior to Metco 442, Metco 82, and some lower carbon materials. Next slide. These are some of the applications. Next slide. These are some of the results that we find with the material. That has an RC40, if the particle cohesion is around 30,000 psi, you can get excellent finishes. The target efficiency is very high, 90 to 95. Now that's target efficiency with this material. And one thing that I didn't really mention is that the scuff characteristics against cast iron is very good. It's about 0.12, which is excellent for this type of material. Next slide. Can we get that changed? What we've done is a cost analysis on. Now, someone might argue and say, "Why should I use 449, which goes at 20 pounds an hour?" The reason for that is that, again, it's target efficiency. You can put more material down on a part because of the narrow spray pattern. Now, my cost estimates were based on using $10 a pound for this material. I think the labor rates I used was $40. What I did was I broke it up into materials, labor, and consumables. And you can see that the highest quality coating is with argon. Okay? It's the most expensive, too. The reason for the higher cost is that the deposit efficiency is lower with argon than it is with any of the other processes. Okay? But you get the best quality coating. Metco 449, as I said, is more expensive than 449P because, again, you have better target efficiency. You also get a better quality material. And Metco 449P is equivalent to 6P and the MDN gun as far as performance and cost. Okay? I definitely feel that this material can be used for a lot of salvage applications.